Hi, in this lecture we will see the dictionary data type in Python. So far we have seen string, list, tuple and set data type. This is the last predefined data type in Python, which is dictionary. We will see how dictionaries work, how to create dictionaries, what are the important methods which are available in dictionary in Python. So let's start. Firstly, introduction to dictionary. What is a dictionary? A dictionary is an ordered. So there is a star here because dictionaries in Python used to be unordered. So if you see the versions of Python which is 3.7 minus, which means all the versions before 3.7 dictionaries were unordered, but like in the newest versions of Python after 3.7, now dictionaries in Python are ordered. Okay, so in the latest versions you will see dictionaries are ordered, mutable, they are always mutable, once created they can be changed, and indexed, collection of key value pairs. They are collection of key value pairs. So here we have indexed, and indexed is also special here. Here the indexing is not on values, like you cannot say this is the position of an element like 0, 1, 2, 3. In dictionary the indexing is done on keys. Okay, so what are dictionaries? They are collection of key value pairs. They are collection of key value pair. So for a key you will store a value, for another key you will store another value, for a key you will store a value, and so on. So you will have key value pairs like this, and a collection of key value pairs is called a dictionary. Okay, the equivalent of this data type in other languages is map. You can create a map, unordered map, ordered map. So equivalent of dictionary in other programming languages is a map, and in Python we create dictionaries to do that. Okay, so you can store a key and an associated value for different key value pairs. So the properties are keys must be unique and immutable. So in Python, when you are storing a key like set, in set whenever you are storing anything, it must be immutable, right? Because it must be hashable. So same thing happens with keys as well. So in dictionary, when you are creating, keys must be unique and they must be immutable. Both the properties we have seen in set as well. The elements of a set must be unique and immutable. Same thing happens with the keys in dictionary. Okay, example strings, numbers, tuples, etc. Okay, only immutable objects are allowed. You cannot have a list as a key in Python dictionary. Okay, or you cannot have a set as a key because list and sets are mutable, and you also cannot have a dictionary as a key because dictionaries are also mutable. So list and set and dictionary cannot be a key inside a dictionary. Okay, and they must be hashable. We will see this property again later, like what are hashable objects, and only hashable objects can be keys in dictionaries. This is because this is how dictionaries are stored in memory in Python. Okay, values can be any object. Values can be any Python object. They can be mutable, immutable, just like an element of a list. You can have any type of object in a list. Similarly, the value in a dictionary can be anything. They can be duplicate as well. You can have same values for different keys. But key cannot be duplicate. Key must be unique and keys must be immutable. Values can be anything. They can be mutable, immutable, they can be duplicate as well. Anything is fine. So these are some characteristics of a dictionary in Python. They are ordered, and they are ordered only as of Python 3.7 plus, which means in the newest versions of Python you will find that dictionaries are ordered. They have made them ordered. Previously they used to be unordered, but now they have an order in which it means that you can actually check that which element you inserted first and then second and so on. So when you print a dictionary, the order of the key value pairs will be same as the order in which they were inserted. Okay, so there will be order, elements maintain insertion order. Whatever order you inserted the elements in, the same order they will come out. Okay, when you print a dictionary, the order will be same as the insertion order. Next is mutable. So dictionaries can be changed after creation. You can change the key, you can change values, you can do anything. You can add more key value pairs, you can delete some key value pairs, you can change some value at a key, you can do anything. Okay, they are mutable, and hence they are unhashable, and hence a dictionary cannot be used as a key in another dictionary. Okay, but it can be used as a value. They are heterogeneous. Okay, so every collection that we have seen except strings was heterogeneous. You can have different type of elements, different data type of elements as keys and as values. So keys can be of different data types and their values can also be of different data types in the same dictionary. So in the same dictionary, you can have an integer as a key and a floating point value as a key and a tuple also as a key. And their values can also be any data type like a list, set or anything, okay? So keys and values can be of different data types. Next is indexed by keys. So in dictionary, indexing is not done by position. So you cannot say dictionary is one element or two element like this. This is not, so here when you index an element in a dictionary, it is not indexed by position. Instead, it is indexed by default by the value of key. So you always index by key. So when we see some examples, it will become more clear. So in dictionary, you do not index by the position. In list, in tuple, in string, we index a particular element by its position. This is at 0th position, first position and so on. That is the index. But in dictionary, the index is the value of key. Okay. So elements are accessed using keys, not positions. You do not use positions for indexing, you use keys. For the last is unique keys. Keys must be unique and they must be immutable. So keys must be unique, duplicate keys, overwrite existing values. If you try to insert another key with the same value, the value will be overridden. Like for a particular key, only a single value can be present. You cannot have same key twice in a dictionary. Okay. So these are some of the properties. Now let's see some examples how to create a dictionary and then we will understand it better. So how to create a dictionary? Again, you have to use curly brackets to create dictionaries, okay? So far we have seen we can use quotes, single quotes, double quotes or triple quotes to create strings. We have seen we use square brackets to create lists. We use round brackets or parentheses to create tuples. And we use curly brackets to create set, and we also use curly bracket to create dictionaries. To create dictionary also we use curly brackets, and that is why when you write blank curly bracket, it will create an empty dictionary in Python. It will create empty dictionary in Python. By default, if you just write empty curly brackets, it will create an empty dictionary in Python. It will not create an empty set. In the last lecture we have seen, if you just write empty brackets, it will not create a set. If you write an element inside it, then it will create a set. Or if you write multiple elements, then it will create a set. But if you just write empty curly brackets, it will not create an empty set, it will create an empty dictionary instead. Because both of them use curly brackets, to avoid confusion, they have made it clear that if you use empty curly brackets, it will create an empty dictionary, not an empty set. If you want to create an empty set, you have to use constructor like this. This is the only way to create an empty set, okay? To create an empty dictionary, you can use empty curly brackets like this. So if you just write S is equal to empty curly brackets, when you print S and when you print the type of S, you will see empty curly brackets, which means it is an empty dictionary, not an empty set. It is an empty dictionary and the type will be class dict, which means it is a dictionary. Okay. And again, you can use curly brackets to write homogeneous or heterogeneous elements in a dictionary. So here the notation is, how do we write it? So the syntax is, you use curly brackets, then you write key, let's say first key, colon, the first value, then comma, second key, colon, second value, comma, third key, colon, third value, comma, and so on. Okay, this is how you create a dictionary. So this colon and comma is important. So this colon actually tells compiler that it is a dictionary, not a set. Because if you don't write colon, it is just a set. If you just write values like this, v1, v2, comma separated, this is creating a set. But if you write key colon value, key colon value, key colon value like this, it will create a dictionary. And you have to be consistent. You cannot write like this. One is a value and then another is a key value pair. Then another you have a value like this. This is not allowed. This is not allowed. You can either create a set or a dictionary. You cannot have a mixture of set and dictionary in the same data type. No. You can either have a set or a dictionary. So if you are writing colons, you have to write colons for all of them. This is not allowed, okay? And if you are not writing colons, you do not write colons for all of them, because this is how set is created and this is how a dictionary is created. So this is the syntax. Colon, if you write colons in comma separated values, it will automatically understand that you are writing key value pairs and you are creating a dictionary. And if you are not writing colons, just comma separated values, compiler will understand you are creating a set. Okay. So this is how dictionary is created. Here we have an example. So a dictionary is created with key as the string name. This is the key. This is the first key. And the corresponding value is the string containing John. So the data type here is a string. A string can be a key because strings are immutable. So a string can be a key, but a list cannot be a key. Okay. So here the value is also a string, that is allowed. And then for the second key, this is the second key. Here it is of type string, and this is the second value corresponding to it, and it is of type integer. So this is allowed. Okay. A string can be a key and value can be anything actually. So you can even have a dictionary like this. Let's say you have a tuple as a key and a list as a value. And then you can have a string as a key and you can have a set as a value. Like this. So here in this dictionary, this is my first key and this is the corresponding value. This is the second key and this is the corresponding value. But note that a list or a set can be used to create a value, but they cannot be used used as a key, because keys must be immutable. They must be hashable. A list and set are not. They are mutable and hence they are unhashable. So they cannot be used as keys. Keys must be immutable. Okay. Tuples and strings can be keys. Again, we will see this concept in detail later. We have seen this concept already in set lecture. Okay, at the end. Okay, so this is how you can create dictionaries using curly brackets. Okay. Okay, now let's see how we can create a dictionary using the dict constructor. Okay, so Python provides a built-in function dict that creates a new dictionary from an iterable. So we have seen like we can create a list, a tuple, a string or a set from an iterable using the list, tuple, str or set constructor, right? Similarly, we have dict constructor or dict method as well in Python. You can use the dict function to create a dictionary from an iterable. Okay, but here is a catch. Like we will see that. Okay, firstly let's see. So the syntax is very like confusing. Dict, mapping or iterable and arguments. So I will explain what the syntax means and why is it so complicated. You cannot pass any iterable to it. The iterable must be a mapping of iterable. Like it should be an iterable which contains key value pairs. Okay, so we will see that. Firstly, if no argument is provided, it returns an empty dictionary. So if no argument is provided in the dict function, it will give you an empty dictionary. So empty dictionary can be created using curly brackets also or using the dict constructor also. And if you don't provide any argument, it will just create an empty dictionary. And when you print empty dictionary will be printed. Type of empty will be dict and the length of empty, which means the size of the dictionary, will be 0. Okay, so this is how you can create empty dictionary in Python. Now, what if you want to actually add some elements? So there are ways to do that. The problem is you cannot give it any iterable and it will convert it into a dictionary. Why? Let's say you have a list containing elements 1, 2, 3, 4. A is a list containing 1, 2, 3, 4. And if you just write dict A, this doesn't make sense, right? This will give you error. Because what is the key and what is the value here? Dictionary is a collection of key value pairs. You need key and value both. And that is why you cannot just create a dictionary with any iterable of values. But if you give it an iterable with key value pairs, like if it is a list containing tuples of two elements, let's say 1 and A, this is a tuple, and then 2 and B, and then 3 and C, like this. So this is an iterable, let's say list containing tuples. Then you can convert this into a dictionary, that is allowed. Why? Here, because like compiler will understand that in this tuple the first value is key and second is value, key and value, key and value, key and value. So by default, if you are giving an iterable with tuples, that can be converted into a dictionary because the compiler will automatically take the first value of the tuple as key and the second value as value, key value like that. So here a dictionary will be created with key as 1 and value as the string A, then key as 2 and value as the string B, then key as 3 and value as the string C, like that. Okay, automatically this dictionary will be created. So you cannot pass any iterable. The iterable must contain tuples. Then only you can use it. So like, and you can also have a set containing tuples or a tuple containing tuple, any iterable, but it should contain tuples of two values. Then only you can create a dictionary like this. And another way of creating a dictionary using the dict constructor is In the dict constructor, you can write, there is another syntax in which you can write key1 is equal to v1, comma key2 is equal to v2, comma key3 is equal to v3, like that. So you can do comma separated inside the dict constructor, and you can say key1 is equal to v1. So here we have equal to. Okay, so don't get confused when you are creating a dictionary using curly brackets. Here we write comma, colon, sorry, key1 colon v1, key2 colon v2, like that, right? But if you're doing it using the dict constructor, then you have to write key1 equal to v1, key2 equal to v2, and so on. Or you can do it this way. So this is another syntax. So here, let's say I want to create a dictionary like this. So 1 is equal to A, 2 is equal to B, and 3 is equal to C. So this will again create the same dictionary, 1A, 2B, and 3C. And it is ordered, which means this will be the first key value pair, this is the second key value pair, this is the third key value pair. Similarly here also, like it is ordered. Okay. So this is how you can create a dictionary using the dict constructor. This is one way where you are using equal to. This is another way where you are giving it a iterable of key value pairs, which means iterable of tuples. And the original way is this, where you can in the curly bracket write key1 colon v1, key2 colon v2, and so on. These are the three ways. Okay. So here let's see some examples. Let's say you want to create a dictionary named person. So you are using the dict constructor to do that. Inside dict we have written name is equal to Bob, age is equal to 30. So here this is the key, this is the value, this is the key, this is the value. So this is equivalent of writing a dictionary in which we are saying name colon Bob, age colon 30. So both are equivalent. Okay. If you are using the dict function, then you have to write equal to. And if you are just using curly brackets, you have to write colon. This is the syntax. Okay. There are two syntaxes. And then the other way is if you have an iterable containing tuples, you can give an iterable containing tuples as well. It will automatically take the first element as key, second as value. Then again first element as key and second as the value. Make sure that you don't have more than 2 items in the tuple. Exactly 2 items in every tuple. Then only it will work. Okay. Because otherwise it will not be able to convert it. So when you convert it into a dictionary, when you print it, you will have A1 and B2. Okay. So this is how you can create dictionaries in Python. There were multiple ways, we have seen all. Now there is one other way in which you can create dictionaries in Python, that is using from keys method. Using the from keys method in Python, we can create a dictionary as well. So it creates a new dictionary with specified keys, all assigned the same default value. So if you have to create a dictionary in Python in which you want to insert multiple keys are inserted and the value is constant, which means all of them have the same value. Then you can do it using from keys method. So like the syntax is dict dot from keys, and inside here you have an iterable. This iterable is the iterable of keys. So all these keys will be inserted one by one, and all these keys will have the same value which you are passing here. So here we have all the keys as an iterable, and they will have the same value. That value you will give it here. So from keys function has 2 arguments. First is an iterable and second is the value. So if you have a use case in which you want to initialize a dictionary in such a way that all the keys have the same value and you have all the keys present in a list or something, then you can use the from keys method. So here let's say the keys are string A, string B, and string C. These are my keys, and I have stored it in a keys variable. It is a list. List is an iterable. So if you write new dict is equal to dict from keys comma 0. So here what happens, let's see. So the keys list is an iterable. List is an iterable and it contains elements string A, string B, and string C. And when I say dict dot from keys, and the iterable keys is keys itself. This is an iterable, and the value is 0. We have given the value as 0. This is the value which will be given to all the keys. So what will happen here? A dictionary will be created in which firstly the key will be like keys will be all these values one by one. So firstly the first element, then second element, and third element, and so on, ordered. So firstly A, and then the value is 0, then B, then the value is 0, then C, again the value is 0. So this dictionary will be created. So if you have such a use case in which you have different keys all stored in an iterable, Here this iterable can contain any number of elements. You can have a set also as an iterable, but then the order is not guaranteed. You can also have tuple as an iterable, or even the range function. You can give the range function here as well. Any iterable is fine. So you can just give the iterable here and it will take all the elements one by one and it will assign the same value in a dictionary like this. Okay. So this is how from keys work. So when you print the new dict here, you will get a comma 0, b comma 0 and c comma 0 like this. And even you can have some complicated iterable as keys as well. So let's say I write dict dot from keys, and inside this I have given an iterable which is range function 1 to 5, and the value is, let's say, value is a list containing 3 comma 4. So don't get confused here. What is happening? These are my keys. Whenever you're writing from keys, these are my keys, and this is taken as an iterable, and this is my value. This is a single value. This always the second argument is a single value. It is not a list here. It is not an iterable. It will be treated as an element. So this element will be assigned as the value for every key. So what are the values this iterable takes? 1, 2, 3 and 4. We know that, right? Because starting point is 1, stopping point is 5, which is exclusive. So we'll stop at 4. Step size is 1. So these are the values it will take one by one. 1, 2, 3 and 4. So here it will create a dictionary in which the key is 1 and the value is the list containing 3 comma 4. And again the key is 2 and the value is the list containing 3 comma 4. Again the key is 3 and the value is the list containing 3 comma 4. And the key is 4 and the value is the list containing 3 comma 4. Like this. Okay. And here when we see, like, we will see memory management of dictionaries. Here actually what will happen, the same copy of this list will be used as the value. Because if you're using list like this, like in list comprehension we have seen this. A single copy of this list will be created, let's say at memory location 123, and all the keys will have the same value pointing to this list. They will all point to the same memory location. So this is not the right way if you want to do it, because even if you change any one of them, all of them will change. So this we will see in memory management how it happens, but essentially this is what will happen, okay? So this will be taken as a single element or value, okay? And this is how the dictionary will be created. Memory management, we will see later how memory management is done in dictionaries. Okay, so we have seen multiple ways to create dictionaries. One is using curly brackets, where we use colon and comma. Then we use dict constructor. In dict constructor, we have seen the first way was you can write key equal to value, and so on. So equal to and comma. The second way was you give it an iterable containing tuples. Tuple containing two elements. So it will automatically take first element as key and second as value. Any iterable that contains tuples. Okay. And the fourth way, which is using dict dot from keys. This is only used if you want to assign multiple keys the same value. So you can give an iterable which contains all the keys and the same value will be assigned to all those keys in a dictionary. Okay, so these are all the ways in which you can create a dictionary in Python. Okay, now let's look at accessing elements in a dictionary in Python. So we can access elements in dictionary using its keys. Only using keys, not position. Although dictionaries are ordered now, okay, but like after 3.7 in Python, dictionaries are ordered. Still, you cannot access an element using its position, which means first, second, third position. It is not possible. You can only access them using their keys. So in the square bracket, generally, like how do we do indexing in list or string? So let's say we have a string, hello. Then this is indexing 0, 1, 2, 3, 4 or -1, -2, -3, -4 and -5. So when we say s of -3 or s of 2, here it is considered as position or index. Whatever we write inside square brackets, it is considered as the position or the index, right? But if we do it in a dictionary, it will not be considered as position or index. So if we have a dictionary like this, let's say we have a dictionary D containing key hello and the value is 5 and there is a key hi, the value is 3 and then there is a key, let's say ABC and the value is 3. Let's say this value is 2, 5, 2 and 3, something like this. Values can repeat also, but let's say these are the like key value pairs. Now if I say D of 2, this will give me error. Because positions do not exist. Indexing, you cannot do indexing using position. By default, when you write index, it will be considered as key only. It will try to see like this key is present or not. So I can say D of high. This is allowed. This will give you the value corresponding to this key, which means 2. Or even I can say D of hello. This will give me the value corresponding to the key hello, which is 5. Right? So always it will try to see the key. So even if you're like writing an integer, like if you say D of 3, it will try to see this key is present or not. Now 3 as a key is not present in this dictionary. If you had a key 3 and value let's say 7, then it is okay. So it will always try to see key, not the position. And like that is why it is not allowed to use position, because what if you have positions also as keys only? Like it might be confusing for the compiler, right? So what I'm trying to say is, let's say you have a dictionary in which you have integers as keys, like 3 colon hi and then 2 colon hello and then 0 colon ABC, something like this. So now if you write D of 2, it will search for key 2. It will only look for keys in a dictionary. So key 2 is present and hence you will get the string hello. So it might be confusing for the compiler, right? What if you are writing D of 1? So it is not the position, it will always search for keys. It is never the position or the index. So although this is at position, like first position, this is at the second position and this is at the third position, because dictionaries are ordered, but still you cannot access them through their position. You can only access them through their keys. If you try to look for D of 1 here, 1 as a key is not present in this dictionary, so you will get error. It will say key error, this key is not present. But if you are looking for D of 2, it is okay. And similarly in this particular dictionary, all the keys are strings. So I can only search for strings. I cannot search for an integer. If I write D of 3, it will give me an error. Okay. So we can access elements in dictionary using its keys. Syntax is dict of key, just like this. In the square brackets, previously we used to write indices. Now we will write the key. And now it will return the value corresponding to this key. So now you can store it in some other variable value or anything. Okay. So let's say there is a dictionary student in which you have name Alice, age 22. So key is name, value is Alice, key is age, value is 22. Now if you print student name, so here we are accessing the value corresponding to the key name. So the value is Alice. So string Alice will be returned by this accessing and the output will be Alice. And if you write print student grade, now grade as a key is not present in this dictionary. And hence you will get an error, you will get key error grade. So it will just say that this key grade is not present in the dictionary, so you will get an error. Even if you write some integer 0, 1, 2, it will give error because that key is not present in the dictionary. So you can only access elements using their keys. If the key does not exist, Python throws a key error. Okay. So this is how we can access elements in a dictionary using its keys. Now there is another way in which we can access elements again using keys, but now the function is get method, get function. Okay, so we can apply the get function on any dictionary. So what is the difference between accessing it using square brackets and using the get function? The difference is the square bracket gives you error if the element is not present. If that particular key is not present, it will give you error. But the get function will not give you an error if the key is not present. It will give you none as the answer. Or you can set a default value also, that will be the answer if the key is not present. So the syntax is dict.get and here you give it the key, and in the comma you can give the default value as well. This is optional. This is optional. If you don't give the default value will be taken as none. None is a keyword, right? It will be none, which means nothing. So if you give the default value, what happens is, firstly, it will try to search for the key. If the key is present, that value you will get. But if the key is not present in the dictionary, it will give the default value which you have provided. And if you have not provided the default value, it will give the none. So the default value of default value is none. If you don't provide default value, it will be taken as none. Okay. So let's see an example. Here we have created a dictionary. The key is name, value is Alice, key is age, value is 22. Now when I print student.get, which means this dictionary, student.get name. So here name is present. The name as a key is present and the value is Alice. So you will see the output as Alice. Okay, but if I say student dot get grade, now grade as a key is not present and I have not given any default value, and hence the output will be none. But if I give the default value, so here I have said student dot get grade, and in comma I have given the default value as well, which is the string NA. So if this key is not present in the dictionary, then this default value will be given as the output, and hence the output will be NA, the string NA. Okay, so the default value will only be given if the key is not present. Here also, if you give the default value, it doesn't matter because this key is present. Alice only will be the output. So this is how the get function works. It will never give you an error. Using square brackets, you might get an error if the key is not present. But using the get function, you will not get an error. If the default value is there, default value will be given if the key is not present. And if default value is not given, none will be given as the output if the key is not present. So it avoids the key error and allows you to provide a fallback default value as well. Okay, this is what the get method does, and it is also used to access elements inside a dictionary. Now we can actually see all the keys which are present in the dictionary and all the values present in the dictionary as well. So dictionaries have a predefined function called keys and values. Keys function in the dictionary, when you apply it, it will give you the list of all keys which are present. Actually, it will not give you a list, it will give you a key type object. Okay, it is a different type of object which is iterable, but it is not a list. It is a different type of object, key, like it's called a view. It will give you a view on the current keys which are present. Similarly, if you use the values function on a dictionary, it will give you a view on all the values which are present in a dictionary. Okay, and these views are iterable. You can iterate over them and also you can print them as well. Okay, so let's see how it works. First is dot keys function. You can apply the keys function on any dictionary. So it is a built-in dictionary method used to access all the keys in a dictionary. If I have to see all the keys which are present, we can do that. So the syntax is very simple. Dict dot keys. It returns a view object containing all the keys in the dictionary. It is a view object. What is a view object? It is not in the scope of this fundamentals course. We will see it later. So what a view means is the current view, which means because since dictionaries are mutable. So, and that is why keys and values can change. And that is why whenever you say dot keys, it will give you the current view of keys, which means currently these are the keys present. Now you can do whatever you want to do, you can do with it. A view object is iterable as well. You can iterate over it. Okay. So let us say here we have a dictionary student in which the key is name and value is Alice, key is age and value is 22, and key is grade and value is A. And if I print student.keys, so the function is dot keys. So student.keys will print the output as dict keys. So dict keys is a class. Don't worry about it right now. So right now it is giving an object of type dict keys. It is a view. Dict keys is a view in which the values are name, age and grade. So see, the output is not a list. Output is not a list. By default, the output of keys method is a dict keys type object, which is just a view. If you want, because see, it is an iterable. It is an iterable. So if you want, you can convert it into a list, because any iterable can be converted into a list. If you want, you can do something like this: print list student.keys. So here what will happen? Student.keys will give you a dict keys type of object, which is a view, which is a complex object. Don't worry about it right now. But it is iterable. So you can convert any iterable into a list using the list constructor. So if you pass this iterable to a list, now it will be converted into a list. So now a list will be printed with the keys in that order. So first is name, second is age, and third is grade. Since dictionaries are ordered after 3.7, so if you're using an older version of Python, which means Python 2 or 3.1, something like that, then the order is not guaranteed. Then you might get keys in any order. But if you're using the latest version of Python, dictionaries are ordered. It means when you are searching for, when you are printing all the keys, they will be in order, like first key, then second key, then third key, like that. So you will get a list containing the first key, which is the string name, then the second key, which is the string age, and then the third key, which is the string grade, like this. So if you want, you can convert it into a list. But even if you don't want to convert it into a list, if you print it directly, still you will see all the keys which are present, okay? Name, age and grade. So this is how you can see all the keys in a dictionary. Same thing happens with values as well. The function is dot values. So it is a built-in dictionary method used to access all the values in a dictionary. The syntax is very simple, dict.values, and it returns a view object containing all the values in the dictionary, all the values. Keys gives you keys, values gives you values in that order, in whatever order the elements are present, okay? So if again you have the same dictionary, name Alice, age 22, grade A, if you print student.values, it returns a dict values type object. It is just a view on dictionary values. So the object is of type dict values, and the values in the dictionary are Alice, 22 and A. So you will get Alice, 22 and A. Again, if you want to convert this particular iterable into a list, you can do that. It is an iterable, okay? Dict keys, dict values, both of them are iterables. If you can use a for loop on them, and also you can convert them into some other type like a set or a tuple or a list, anything you want. You can just use the constructor and convert them, okay? So here we are getting the values inside the dictionary. So this is how you can get the keys and values. Now if you want to get the key value pairs inside a dictionary, if you want to get both keys and values both, if you want to get the key value pairs, then you can use dot items. Okay, so there are three important methods here. Dot keys, this gives you all the keys. The type is dict keys. The type is dict keys. Don't worry about it, what it is, but it is iterable. It is an iterable. You can convert it into a list or a tuple, whatever you want. You can even iterate over it. Then you have dot values. It gives you dict values. Again, it is an iterable. And then we have dot items. Dot items gives you key value pairs. So it will give you an object of type dict items. Again, don't worry about it. It is just like tuple containing key, comma value, key, comma value, key, comma value. It will be a tuple containing key value, key value, key value. So it will give you ideally dict items. But again, it is also an iterable. It is also an iterable, so you can iterate over it, or you can convert it into some other data type like list if you want. So if you convert it into a list, you will get a list of tuples containing key, comma value pairs. Okay. So it will give you a list of tuples. But right now it will be of type dict items. Again, we can convert it if you want. So it is a built-in dictionary method used to access all key value pairs in a dictionary. Dict.items, this is the syntax. It returns a view object containing key, comma value pairs, which means tuples. Pair is a tuple in Python. So it will give you key, comma value tuples as tuples from the dictionary. Okay. So if we have this dictionary student containing name Alice, age 22, grade A. If I print student.items, I will get dict items in which there is tuple name Alice, age 22 and grade A. Now if I want, I can iterate over all these elements. So I can take a tuple key, comma value, then key will take this value and values will take this. This thing we have seen in for loop, how you can iterate over dictionaries, okay? In this lecture, we will see in detail how internally it works, okay, as well. So if you want key and value both for the entire dictionary, you can use the dot items function inside a dictionary. Now next is size of a dictionary, very simple, just like the size of a string or a list or a tuple or a set. We can use the len function on a dictionary as well. It will just give me how many key value pairs are present. It will consider key value pair as a single element. Key and value are not separate. Key value pair will be a single element. So how many key value pairs are present? That is what you will get. Returns the number of key value pairs in the dictionary. So if you have a dictionary, this is a key value pair, this is a key value pair, and this is a key value pair. And hence, if you print the length of this, you will get the output as 3. So len function works on dictionaries as well. Now let's see how you can loop through a dictionary, which means how you can iterate over all the elements in a dictionary. So again, dictionary is a key value pair. Dictionary is a key value pair. Right? So you can iterate over all the keys if you want. You can iterate over all the values if you want. And you can iterate over both key value pairs also if you want. So if you want to iterate over only keys, you can use the dot keys function. It will give you all the keys. If you want to iterate over all the values, you can use the dot values function. This will give you all the values. And if you want to iterate over key and value both, you can use the dot items function. This will give you tuple, which will be having keys and values both. So since all of them give you an iterable, you can iterate over them. Okay. So if you want to loop through the keys of a dictionary, let's say there is a dictionary containing name Alice and age 22. Then you can write for key in student. See, for key there is a special thing. You can use the dot keys function also. This will also give you keys. And even if you don't use the dot keys function, by default, if you just iterate over the dictionary directly, if you iterate over a dictionary directly as an object, then also you will get keys only. So dot keys, and even if you don't write dot keys, you will get keys only. So if you like for any dictionary, let's say if I have a dictionary 1:A, 2:B, and 3:C, then if I write for K in D, so by default this dictionary will only give the keys, not the values. It will only give the keys. So by default, if you iterate over a dictionary, you will get the keys. So K will take the keys as an iterable. So it will give you 1 and then 2 and then 3. So by default, automatically the compiler will call the d.keys function only, okay? So you will get the keys 1, 2 and 3. So if you print K, you will get output as 1, then 2, then 3, okay? And you can always get the corresponding value. Getting the corresponding value is simple. For any key, you can get a value, but for a value, you cannot get a key. Dictionary is a data type which works like that. When is a dictionary used? It is a map from key to value. Generally, like this is how the use cases will be. Okay, it's like a database. So for a key, you can get a value, but for a value, you cannot get a key. For that, it will be a very difficult thing to do. But for a key, if you want a value, that's a very simple task. That's just indexing. And that is very fast also. Okay. So if you're iterating over a key, basically you can get the value also just by like indexing it. Okay. So let's see what this piece of code does. If you write for key in student, it like key variable will take all the keys, which means firstly it will take name, then age. So if you're printing key and student key means what? Here we are indexing the student dictionary using the key. So it will just give me the value. So the key will also be printed and value will also be printed. Although we are iterating only on keys, but when you are iterating only on keys, you can actually access values as well, corresponding values as well, okay? So this is what you can do, and same thing you can do with the keys function. So you can write for key in student.keys. We know that keys function returns a dict key object, which is a view on current keys, and which is iterable, so you can iterate over it. It will just give all the keys one by one, firstly name and then age. So both are same. Here for both of them, the output will be name and then the value Alice, age and then the corresponding value 22. Okay, so this is how you can loop through the keys of a dictionary. Similarly, you can loop through the values of a dictionary as well. For that, you can use the dot values function. This gives you a view of the current values in that order. So firstly Alice and then 22. So if you run for value in student.values, if you print the value, you will get Alice and then 22. Because dot values function gives a dict values type of object. Okay, which is an iterable. So it gives all the values one by one in that order. Okay, so it is an iterable and you can iterate over Alice and then 22 like that. Cool, so this is like looping through values of a dictionary. And now lastly, if you want to loop through the key value pairs, which means key and value both in the same loop, then you can use the dot items function. This is the most important function. The most commonly used function is dot items because it takes care of everything. This will give you key value pairs, just like enumerate function. Enumerate function gives us index and value both. So items function also does the same. It gives you an iterable over key value like that. So it will return tuples. In the iterable, the first element will be a tuple, second will also be a tuple, then the tuple and so on. So this is the first key value pair, second key value pair, third key value pair and so on. Okay, so it will give you tuples. So student.items is an iterable that will give you key value pair as tuple. So firstly it will give you the string name and the string Alice, the key value pair as a tuple. Then the second element this iterable will take is a tuple containing the first element as age and second element as 22. Now we can use tuple packing and unpacking. We can actually unpack this particular tuple into another tuple of variables, key comma value. So if you want, you can write the bracket and you can skip the bracket as well. We have seen tuple unpacking and packing, right? So you can actually unpack this tuple in this tuple. So key will take the first value in this tuple and value will take the second value in this tuple. So automatically always key will take the keys and value will take the corresponding values. Now you can print key and then like arrow and then value. So here the key and value will be printed. So a name Alice, age 22. This is how you can iterate over key value pairs in a dictionary. Again, like if you don't want to calculate the value like this, you can just use the key and you can do dict of key as well. But the problem will lie if you want to find a key for a value. The opposite thing we cannot do. We can only do one-sided. For a key, we can find the value using indexing. Okay, so this is like this is how we can loop over dictionaries in Python. Okay, now let's see how we can add entries in a dictionary. Okay, so first is again using a square bracket notation. Okay, very simple. It's very simple. What it does is, let's say you have created an empty dictionary. Now in this empty dictionary, right now in memory an empty dictionary is created. Let's say this is my empty dictionary. At let's say memory location 756 and variable d is pointing here. Now if I just write d of key is equal to value, this is the syntax, that's it. You just have to write d of key is equal to value. It will automatically assign a value to a key. If this key doesn't exist, it will insert a key. So it will firstly see if this key is already there. If this key is already there, it will update the value. So the same syntax updates the value as well, and it also inserts. It updates the value and also it inserts. So if the key already is existing, then it will update the value of it to the new value which you are giving. And if this key doesn't exist, it will insert a new key comma value pair inside the dictionary. So right now there is no key comma value. So if you just write d of let's say string abc is equal to 3. So this will be the key and this will be the value. Right now the string abc is not existing as a key in this dictionary. There is nothing in the dictionary. So it will insert a key value pair abc comma 3. So it will just insert abc, key abc has a value 3 in the dictionary in memory. Okay, internally how is it managed? It uses hash table to hash the key. That is why key has to be hashable. It will store the hash values. Okay, so again we will see hashing in algorithms. There we will see how sets and dictionaries are managed internally in memory. Right now we cannot. After seeing hashing, it will be clear. Okay, so this is just I am giving you as a reference. Okay, internally this is not how it is done in memory. It will store the hash value of the key and corresponding value and like that. Okay, now if I say let's say d of def g is equal to 4, then this is the key, this is the value. Again this key is not present, so it will insert it def g and the value is 4. Now let's say after this I again write d of abc is equal to 7. I have written the same syntax, but right now this key is available. This key is already present in the dictionary. ABC as a key is already present in the dictionary. So now what will happen? The value will update. So here in these two statements we were doing insert, but using the same syntax here I am doing update. The reason is this key was already present and hence now it will update the value of this key to 7. So now this key will have now instead of 3 the value will be 7 like this. Okay, it will be updated to 7. And that is why keys must be unique. You cannot have a duplicate key, because if you are inserting the same key again, it will not insert the key comma value pair. It will just update the value, that's it. Okay, and that is why all the keys in a dictionary will always be unique. You will never have duplicates, but value can be duplicate. I can again now say d of def is also 7. So this will also work as an update and this value will also become 7 now. Okay, values can be duplicate but keys cannot be. Okay, so this is how you can insert and update elements just using the assignment operator. I can add any key to a value. I can insert also and update also using the same square brackets. I can do that. So first is using a square bracket. The syntax is dict and then you can write a new key here and a new value here. So this is the syntax. Let's say you have a dictionary name student, name Alice and age 21. And if I write student grade is equal to A, since grade as a key was not present, a new key comma value pair, which means grade comma A, will be inserted in the key. And now if you print student, you will see name Alice, age 21 and grade A. Order is maintained. Firstly these two were inserted, now this was inserted. So in the same order you will get the output. So if the key already exists, this will update its value instead of adding a new one. Okay, we have seen this. So this is how you can add entries to a dictionary using square brackets. And again, updating entries in a dictionary, we have the same syntax. If you want to update the value of a key, you cannot update a key, okay, in dictionary. You can never update a key directly in a dictionary. To update a key, what you have to do, you have to remove the pair entirely and insert a new pair. You can update the value for a key. See, the entire dictionary concept is based on key value pairs. Okay, and key is the key, right? So it is entirely based on the key value pairs. If you want to update a value, that is very simple. For the same key, if you give a new value, the value will be updated. But if you want to update a key, let's say what happens is, in a dictionary you have, let's say, 1A and 2B. If I want to update the value of for key 2, I can directly write, let's say D is this dictionary. D of 2 is now C. So the value will be updated. But what if I want to update the key 2 to 3 now? That we cannot do. That is not possible. For that, you need to insert a new key 3 with the same value B. Then 3 comma B will be inserted. And then you have to remove this key value pair completely. That's how you can do it. Okay. You cannot update a key in place. That is not possible. You have to update a new pair, add a new pair and delete the previous pair. Okay. So how to delete and how to add, we already know. How to delete, we will see shortly. Okay. Cool. So this is updating a value for a key. So if we have a student dictionary, name Alice and age 21, if I write student age is equal to 22, since age as a key was already present, now it will update its value. Now the age, instead of 21, it will become 22. So it updates existing key. So same syntax is used for insertion as well and updation as well. Now if you print a student, the output will be name Alice and age 22. The value was updated. Okay. And you can update an element using the update method as well. So update method is used if you want to insert multiple keys at once. Okay. So update method is used just like extend in list. If you want to insert multiple elements. So update method will take an iterable. It will take an iterable of key value pairs. And it will insert all of them inside the dictionary. And while insertion, again, it will do the same thing. If the key value pair is not present, it will insert the key value pair. And if the key is already present, it will just update the value. Okay. So let's take an example here. Let us say we have a dictionary. Okay. If we have a dictionary containing key values pairs 1A, 2B, 3C, like this. And if I say now d.update, and in the update function you can give an iterable. In the update function you can give another dictionary. Okay, so the update function takes another dictionary. So let's say I updated it with another dictionary. Let's say 1K, 4M, 5N and 3P. This is the dictionary which I have given. So update function takes another dictionary and it will insert all the key value pairs in this dictionary to this dictionary. So it will add this entire dictionary to this dictionary. So how will this work? Inside the dictionary D, what will happen now? In memory, what is there? There is a dictionary present and D is pointing here. Let's say at memory location 756. We have a dictionary. And right now the dictionary contains 1A, then 2B, then 3C. So when you are running this update operation, firstly the first key value pair will be added, 1K. So 1 is already present as a key. So its value will be updated and now at 1 the value will be K. So this value will now become K. Okay. So this is done. Now you have 4M. 4 as a key is not present. So 4, M pair will be added. 4 key and value is M. Now if you're adding 5N, 5 as a key is not present in this dictionary, so 5 will be added as the key and the value will be N. And now we have 3P. So 3P is 3 as a key is already present, so just its value will be updated to P now. So now the value of 3 will be P. So now this is the dictionary in this order. So now if you print the dictionary, the answer will be 1K, 2B, 3P, 4M and 5N. This will be the output in the dictionary if you print it after the update. So update function again performs insertion and updation both depending on the key is present or not, and you can give it another dictionary. Dictionary is an iterable, so it is an iterable of key value pairs. So you can give it another dictionary and it will update all the items in this dictionary with the original dictionary. So in place now D will point to this dictionary. So this is how the update function works. Let's say the dictionary is name Alice, age 21, and now we are saying age 23. So now value of age will be changed to 23 and we are saying gender female. Gender is not present in the dictionary. So another value gender female will be added. And now this will be my dictionary. So when you print the student now, name Alice, age 23 and gender female will be printed. So if the key exists, the value is updated, and if the key doesn't exist, key value pair will be added in the dictionary. This is how the update function works. Update function takes another dictionary or an iterable as an argument. Okay. Now how we can delete entries from a dictionary? This is all we have seen, addition and updation. And now what if I want to delete a key value pair? I told you, right? What if I want to change a key itself? Then I have to delete that particular key value pair and insert another key value pair. So that you can do using the del statement, del. So del is a keyword in Python. And using the del statement, I can delete any key value pair from a dictionary. Del is a keyword that we have seen in the 35 keywords list. And using the del keyword, the syntax is very simple. Del, dictionary and key. So if you just give the dictionary name and the key, it will delete the key value pair, everything. The key and the corresponding pair, that will be deleted. So let's say if you have a dictionary data is equal to A1, B2 and C3. So in memory, this will be like this. Let's say it is a dictionary at memory location 756 and data variable is pointing here. So here you have a dictionary A1, string A, key is string A and value is 1, then B2 and then C3. Okay, and if you do delete data B, so this entry will be deleted from the dictionary, that's all, the entire key value pair. So because we have said delete data of B, so data ka B element is this, so this will be deleted. And now when you print data, A1 and C3 will be printed. So this is how you can change key as well. If I have to change the key B to D, so I can delete it and add another value D4, let's say, D2, let's say. So you can add this, right? So here we have just changed B to D. But you cannot change key in place. You have to delete the row, like key value pair, and add another key value pair if you want to do that. So this is how you can delete a key value pair in the dictionary using the del keyword. Del, data and B. So and also it will raise a key error if the key is not found. So always be mindful, if the key is not present in the dictionary, then it will, if that particular key is not present in the dictionary, it will give you a key error. That particular key is not present and the program will stop. Program will stop, you will get an error. So always be mindful, only if the key is present in the dictionary, then only you can use the delete. So how do I check if a key is present in a dictionary or not? You can use the membership operator. So for a dictionary, membership operator, which means in and not in, will only check the key. So if I just say k in dict, so it will just check that this particular key is present in the dictionary or not. By default, if you just write the membership operator, it will only check for the key, not the key value pair. So I can directly say that here. So if I have to be like, if I have to delete and if I have to write an error-free code, I should write it like this. Let's say I want to delete key, which has like, let's say I want to delete the key variable and it stores the actual key, and I want to delete this particular key from the dictionary which has a name D. So I can just write if key in D. If key in D, then only I will delete this particular key. Delete D of key. Now this key variable can contain any key, but this is an error-free code. So firstly, it will check this key is present in the dictionary or not. So the membership operator will tell you that this key is present as a key in the dictionary or not by default. Or I can also say key.d.keys also. D.keys also. That is also fine. Because keys also gives you all the keys. But by default, even if you don't write keys, if you just write the dictionary name, that also will give you keys only. This is what we have seen while looping. Okay. So it will only give you keys only. So it will check firstly key is present as a key in the dictionary or not. If it is not present, it will not go inside and it will come out. If it is present, it will delete the element. Okay, so this is the error-free code for deleting a key value pair in a dictionary in Python. Okay, so we have seen the del keyword to delete a key value pair in a dictionary in Python. Another way of doing the same thing is using the pop function given in dictionary. Okay, so using the pop function, again same thing happens, exactly same as del. So it will delete the corresponding key value pair which you provide as key here, and it will also raise a key error if the key is not found, exactly as del. Okay, but del is a keyword, it is not a function available for dictionaries. Del is a keyword that works independently. For dictionaries it works that way, but dictionaries also have a pop function that like we have pop function in list as well, right? If you provide any index, that index element is deleted. Similarly for dictionary, if you provide any key, that key value pair will be deleted. So it removes the key and it returns its value as well. So it will return the value when you, like if you want to see what value was there when you deleted this key value pair, you can just store it in some other variable value and you can print the value, the corresponding value that was deleted. Because key you already know, you deleted that. If you want to see the value also that was deleted, you can store it in some other variable or you can print it here itself. So same concept, if we have a dictionary containing A1, B2 and C3, if I just do data.popc, this key value pair will be deleted and the value will be returned. So 3 will be stored in the variable value. You can print it and 3 will be printed. And if you print the data, which means the dictionary now, you will just see A1 and B2. So you can use it on dictionary directly, dictionary.pop, and then you can pass the key. Always again note that this will also raise a key error if the key is not found. So the program will stop. Again, if you want to write error-free code, firstly check. So if that particular key is present in dictionary, here the dictionary was data. Firstly check, then only you pop. So here the key was what? The key was C. So firstly check, if this C is in dictionary, then only you pop it. Data.pop C. Okay. So this is the error-free version of this. Okay. So this is how the pop function works. It works exactly same as the del keyword. Now there is a function called pop item. Pop item function in a dictionary deletes the last inserted key value pair by default. So it removes and returns the last inserted key value pair, and it is only there in Python 3.7 plus. Because in earlier versions of Python, dictionaries were unordered. So there was no concept of last inserted value. There was no order at all. And hence there was no pop item function available. But now in the newest version of Python, pop item function is available for a dictionary. It deletes the last inserted value in the memory. So in the dictionary, whatever is the last inserted key value pair, that will be deleted. So let's say here data is a dictionary. So in memory, this is how it will be stored. Let's say at memory location 756, data is pointing here. Now if you enter x colon 10, so x 10 will be inserted, then y colon 20, so y 20 will be inserted in the dictionary. Now if you say data.pop item, data.pop item, it will delete the last key value pair and it will return the last key value pair. It will return the last key value pair. It will not just give you the value, it will give you the key value pair as a tuple, whatever is deleted. Why? Because here you don't know the key. In the pop function, you already know the key. So that is why it doesn't give you the key, only the value. But pop item function, you are not giving any key. So that is why it will return you the key value pair and you can store it in a variable. And when you print it, both the key and the value which is deleted will be printed. So here the last entry is y comma 20. So this will be deleted and this as a tuple will be returned. And when you print it, y comma 20 will be printed. And if you print data, which is the dictionary now, it only contains a single key value pair x10. So that will be printed. And this one will raise a key error if the dictionary is empty. Because if the dictionary is empty, there is no item to delete. So you must check it first. If the dictionary is empty, you cannot run this command. It will give you an error because there is nothing to delete. Okay. So this is how the pop item function works in dictionaries. And finally, we have a clear method. We had a clear method for all the mutable objects. See, immutable objects, you cannot do anything in place anyway. So for a tuple or for a string, we don't have a clear function because you cannot delete elements. You have to delete the entire variable if you want to do that. But in mutable objects, we always have a clear function, which means for a list, for a set, and for a dictionary, we have the clear function, which will delete all the elements present inside the data type. So here, if you want to delete all the key value pairs which are present in a dictionary, you can just use dot clear function. It will clear everything. Now the dictionary will become empty. In place, it will delete all the entries at the same memory location. Now nothing will be present. And now let's say if you have a dictionary x10 and y20, if you print data after clearing, you will just get an empty dictionary as output. All the values will be deleted. Okay. So it works exactly like it works in list or in a set. So this is the clear method for dictionaries. Now again, the sorted function also works on dictionaries. Sorted function works on strings, list, tuples, sets, everything. It always gives you a new sorted list. It always gives you a new sorted list. No matter what you work on a string or a list or a tuple or a set, if you pass any iterable to the sorted function, it will just sort it and it will give you a list, right? Same happens in dictionary as well. If you just pass a dictionary inside the sorted function, it will give you a new sorted list of dictionary keys. It will only give you keys as the output, not the values. So if you pass a dictionary to the sorted function, it will just sort all the keys and it will give you all the keys sorted in a list. So if you have B2, A3 and C1, and if you just pass this dictionary in the sorted function, by default it will only give you keys, which is A, B and C in sorted way. So the output will be a list containing A, B and C. Okay. Now if you want the key and value both, see why is this happening? Because the name of the dictionary by default only gives you keys. That is why when you iterate, if you say for X in a dictionary D, if you print X, only keys are printed. And even if you write the membership operator X in D, by default the name of the dictionary only gives you keys. So in membership also it will only check keys. And same happens in sorted as well. If you pass a dictionary in the sorted function, D is an iterable and it only gives the keys. So the name of a dictionary by default is an iterable on keys only. So you write D or you write D dot keys, it's the same thing. Okay. So always keep this thing in mind. But if you want to sort key value pairs both, then you can use items, right? So you can say sorted and you can give D dot items. Now items function in a dictionary gives us a list containing or an iterable containing the tuples, which means key and value both. Tuples of key and value, key and value, key and value, like that. So this will now be sorted, which means firstly keys will be sorted, right? Sorting always works in lexicographical order. So only keys will be sorted. Keys are anyways distinct. So keys will be sorted and values will also be preserved. So now this sorted function will give you a list containing key value tuples. So if we just like what is happening here in this piece of code, let's see. B2, A3, C1. So the dictionary D contains B2, A3, C1. And if you pass it in the sorted function, sorted of D dot items. So D dot items now gives you an iterable. This iterable contains what? The key value pairs, which means B, 2 and then A, 3 and then C, 1. This is the iterable. So now all these three tuples will be sorted. So now the new tuples that you will get is A, 3, then B, 2 and then C, 1. This is the sorted version of these tuples. And the sorted function always gives you a list. This will always give you a list. So the output of this will be this list. Now you can convert this list of tuples into a dictionary again if you pass it in the dict constructor. So if you pass it in the dict constructor again, this list now again will be converted into a dictionary. So now you will have A3, then B2, then C1. A new dictionary is created here. So now you can store it in some other dictionary D2. So now D is the original dictionary and D2 is a new dictionary containing all the key value pairs, but now keys are sorted. Okay, and since dictionaries are ordered in the newest version of Python, it makes sense. Here the order was different and here the order is different. So if you want to create a new dictionary, you can do it like this: dict, then sorted, then D dot items. This is the way in which you can sort a dictionary on keys and create a new dictionary out of it. Okay. Just understand the functions. Like sorted function can take any iterable, if you're just giving the dictionary name by default only gives you the keys. So only keys will be given. But if you do key d dot items, this is another iterable but on tuples. So now if you sort it and convert it again to dictionary, you will get a new dictionary with keys sorted. Okay. So this is how the sorted function works on dictionaries in Python. Now, very important concept, I told you, all the keys in Python must be hashable, because internally when you store a dictionary in memory, the hash value of the key is calculated and they are stored using their hash values. And we have seen the concept of hashable in set as well. All the elements in a set or a frozen set must also be hashable. And hence in dictionaries, keys must be immutable and hashable. Only immutable objects are hashable. Mutable objects can change values and hence their hash value can change, and hence mutable objects don't have the hash method. Only immutable objects have the hash method. So a tuple will have a hash method, or a string will have a hash method, right? So, and integer, float, complex, all the normal like boolean, all the normal data types which contain single value also are immutable. They also have the hash method. And if you want to check the hash value of any object, okay, we will see it in demo. You can use the hash function for that. You don't need to import any library. Just inside the hash function, you can pass anything. Like let's say if you want to check the hash value of a tuple, you can do it like this. So this is what, like, the hash function is used in the set in a set and in dictionary keys. And if you pass an unhashable type, it will give you an error. So in the demo, we'll try to see this. So yep, an object is hashable if it has a hash method. It can be used as a key in a dict or as an element in a set. So an element in a set and a key in a dictionary must be hashable and it must be immutable. So you cannot have a list as a key, okay? And you cannot have a tuple which contains a mutable object like this. So this also cannot be a key, although it is a tuple which is immutable, but inside it contains a mutable object and hence it is unhashable, okay? So its hash value doesn't change during its lifetime. So, but for this tuple, the hash value can change and hence it is unhashable. So mutable types like list, set and dict are not hashable and they cannot be a key in a dictionary. Only immutable types or hashable types can be a key in a dictionary. So this is very important concept. Now we have a concept of nested dictionary. So what do we mean by a nested dictionary? A dictionary inside a dictionary. But I told you dictionary is mutable. Dictionary is mutable and hence dictionary is not hashable. And hence a dictionary cannot be a key for another dictionary. Notice, like, see, the series of events is what? Dictionary is mutable. And all mutable objects are not hashable, unhashable. And a dictionary key must be hashable. And therefore, a dictionary cannot be a key in dictionary. But values of a key can be any object. Values of a dictionary can be any object. It can be hashable, it can be unhashable as well. And that is why, therefore, a dictionary can be a value inside a dictionary. Okay? So this is the concept. So when I say nested dictionary, a dictionary can only be present as a value inside another dictionary. But you can create a dictionary like this, right? A dictionary containing key as 1 and the value is another dictionary containing key as 2 and the value is another dictionary containing key as 3 and value is, let's say, C, and this is closed, this is closed, this is closed. So here the original dictionary is containing one element where the key is 1 and the value is a dictionary containing a single element. This is again a single element containing key as 2 and the value is another dictionary containing key as 3 and value is C. So this is a nested dictionary. Dictionary can only be a value, it can never be a key. Okay, so this is how you can create it, a nested dictionary. So let's see an example. A nested dictionary means having a dictionary inside another dictionary. Here is a complex dictionary given this is like JSON object. If you learn like what JSON objects are, it is not part of this course, but JSON objects look like this. So it is like formatted structure. There is a student with name Alice, and marks is like, you inside the marks you can have another dictionary, like the marks in maths is 85 and science is 90. And if you want to add address, inside the address you can have another dictionary in which city is Hyderabad and pin code is 50001. Okay, 5, 4 times 0 and 1. So this is how you can create a dictionary. See, observe that here values are dictionaries, and that is possible. Now how do you access elements here? So if I say student marks, what is student marks? The value is a dictionary. So student marks means this dictionary, right? So student marks means it is a dictionary. Now if inside the dictionary I am saying math marks, so now inside the dictionary I am saying what is the marks in maths, so the answer will be 85. So this is how you can access nested dictionaries. Student marks math, you will get 85. Now student address city, what is student address? Student address is this dictionary, right? And inside that we are saying what is the city, so the city is Hyderabad, so Hyderabad will be the answer. So this is how you can access nested dictionaries, a dictionary inside dictionary, you can access them like this. And even you can change elements if you want. Since dictionaries are mutable, dictionaries inside them are also mutable. If you want to change the value, you can change the value to 90. Then this value will become 90 now, like that. So you can add add elements inside the dictionaries. All the functions will work exactly the same. And nested, this is how nested dictionaries work in Python. Okay, now let's look at dictionary comprehension. So just like list comprehension, we can create an entire list in a single line. We can write the for loop and even the if condition inside the single line, inside the square brackets itself. So same we can do for set and dictionary as well. Basically for all mutable structures we can do that because they are mutable. So in the same line we can add them using comprehensions. Okay, so comprehension provides a concise way to create dictionaries from an iterable. So directly in a single line, you can create a dictionary itself. So here again, like in list comprehension, here we had expression. So here the expression will be key expression colon value expression. We have to write key and value both. Then we can write the for loop. Now generally here we will have for item in iterable and the expressions will involve item in some way or the other. So let us see an example. Here we have nums equal to 1, 2, 3, 4. Nums is a list which is an iterable. We can use any iterable in the for loop. Okay, and we have written squares is equal to n colon n to the power 2 for n in nums. What does this mean? This is equivalent of writing firstly define an empty dictionary, squares, exactly like list comprehension. Okay, define an empty dictionary. Now you can write for num in nums, for n in nums. Now here we have written n colon n to the power 2. It means that we are adding a value with key n and value as n square, n to the power 2. So we can write squares of key. Key is what? N is equal to value. Value is what? N to the power 2. This is what this code is doing. So for all values in nums, which means n will take value 1, 2, 3, 4, we are adding 1 and corresponding square. So at the end of the day, squares dictionary will contain 1 colon 1, 2 colon 4, 3 colon 9 and 4 colon 16, because these are the values which n takes. So n, n square, n square, n square and n square. So that is how you can create an entire dictionary in a single line of code. This entire piece of code can be written in this single line. Okay. So the dictionary will be 1, 1, 2, 4, 3, 9, 4, 16. This comprehension can only be done on mutable objects like list, set and dictionaries. Same way it will happen. Okay. It's just that if you're creating a set, again you will use curly brackets. If you're using a list, you will use square brackets. That's it. For tuples are immutable, strings are immutable, frozen sets are immutable. They cannot be created using comprehensions because comprehensions do what? They add items one by one. And tuples and strings and frozen sets are immutable. So you cannot add items one by one in them. Okay. And that is how it happens. And similarly, you can write the if condition as well. Even squares is equal to n square for n in nums if n% 2 is equal to 0. It means that only if n is an even number, then only we will add its square. So here 2 and 4 are even numbers, and hence only 2 and 4 squares will be added. Okay, we already know how this code is written. You just have this if condition here as well. Okay, so if you want to see detailed lecture on list comprehensions, you can see the lecture of list. There we have discussed in detail how comprehension works. Same way here we are doing it for dictionaries. Now here we have more examples. Let's say original dictionary is A1, B2. Now we are creating a reverse dictionary. So which means we want key to be the value and value to be the key. So we can do it using the comprehension. We can say that reverse dictionary is equal to V colon K for K comma V in original dot items. Now original dot items will give tuples. It will give tuples like A comma 1 and B comma 2, right? And these tuples will be unpacked in K comma V. So K will be the key and V will be the value. And now when we are creating the new dictionary, we are saying V colon K, which means now value will be the key and key will be the value. Okay, so we swapped them, and hence now the new dictionary will be created with 1 as the key and A as the value, and 2 as the key and B as the value. Okay, so this is also you can do using dictionary comprehension. And we have another example in which we have two loops. So for I in range 1, 3, this is the outer loop. This will take values 1 and 2. And for j in range 1 to 4, this will take values 1, 2 and 3. So this is the outer loop, this is the inner loop, and we are just adding the key is tuple I comma j. So firstly I will take value 1 and j will take values 1, 2 and 3. So the keys will be 1, 1, 1, 2 and 1, 3. Then I will take value 2 and j will take values 1, 2, 3. So the key will be 2, 1, 2, 2 and 2, 3. And their corresponding values are I into j. So 1 into 1 is 1, 1 into 2 is 2, 1 into 3 is 3, 2 into 1 is 2, 2 into 2 is 4, and 2 into 3 is 6. So this is how you can write two for loops in a single comprehension. Again, we have discussed in detail how it works in the list comprehension lecture. You can check it there. The same way we are just creating dictionaries here. Okay. Okay. So now what are the use cases of dictionaries? Why should you use dictionaries? So these are some of the use cases. Fast lookup. So if you have a use case in which you want to very quickly see what is the value corresponding to a key, you can use dictionaries. So it is very fast, ideal for storing and retrieving data by a unique key. Okay, it is the fastest way in which you can find an element present with a key. Again, counting, the second is counting frequency. So if you have to find, like in any collection, how many times a particular element occurs. Let's say you have a string B-A-N-A-N-A, banana. In this string, B occurs 1 time, A occurs how many times? 1, 2, 3 times, and N occurs 2 times. So if you have to create a structure like this, you have to use dictionaries, right? And there is a library that does this thing on its own. Okay, if you want, you can do it using for loop also. Using a for loop, you can iterate over all the items. You can create a dictionary and increase their counts. You can do that. But there is a predefined library called counter. We will see that in the coming slides. So counter library will create this dictionary on its own. It will just count how many times every item occurs in a collection, and it will store it in a dictionary. Okay. Okay, so we will see the counter library, how it works, how it creates this dictionary on its own. Next is grouping data. If you have to group data together based on keys, you can use dictionaries. Next is storing object properties like JSON. So we have seen an example. You can create nested dictionaries. So you have to store properties of certain object like a person, what the name, age, height, weight, something like that. So to store things like that, like in a JSON format, you can use dictionaries in Python. JSON can be converted to dictionary. Dictionary can be converted to JSON directly. There are libraries for that, and you can store them in dictionaries in Python. Then representing graphs in adjacency list. So when we see graph data structure in data structure and algorithm, there we will see that graphs are represented in a particular way, and we will see that any vertex can be connected to any number of vertices. So if you want to store that, like vertex number 1 is connected to which vertices, let's say in a tuple you can do that, and vertex number 2 is connected to which vertices, and so on. You can use dictionary data type for that. So like it is very simple, and if you want to check like which vertex is connected to which vertices, you can do it very fast. So when we see graphs and when we see competitive programming problems on graphs, we will use dictionaries heavily there. Okay. And next we have memorization or caching. So when we solve dynamic programming problems, again like dynamic programming graphs, all the complicated problems which are there in competitive programming, okay, in all of them we use dictionaries a lot. So dictionaries have a lot of use case. When we see DSA and when we solve DSA problems in Python, there we will see how to use dictionaries there, okay. So it is one of the most important data type which is available in Python because it is actually equivalent of map. So in competitive programming, if you use C++, we use map a lot. Similarly, if you are doing it in Python, we use dictionaries a lot, okay. Okay, now let's see dictionary copying. What if I want to create a copy of a dictionary? So again, same concepts for shallow copy and deep copy work for all the data types. We have seen shallow copy and deep copy first in the list lecture. Again, you can watch that lecture first if you have not already. There we have discussed the copying concept, like what is shallow copy and what is deep copy in detail. Let us see how it will work in dictionaries. So here we have created a dictionary D1 with key A and value 1 and key B and value 2, 3. So values are again stored in some place else. If a value contains an iterable, which means if a value contains a collection like a list or a tuple or another dictionary, then all these collections will be stored in some other memory address. So how will the memory be managed here? So let's say this is the place where the dictionary is stored. This is the place where the dictionary is stored. So it will have key and a value. Key and value. Like this. So let's say it is at memory location 756. And point like D1 variable is pointing here. Now we have A:1. So for the key A, we have value as 1. And for the key B, we have value as 2, 3. So since it is a list, the list is never stored directly in memory. So list will be stored in a separate place in memory and you will just have a pointer here. So here you will have a pointer to a list that is present somewhere else that contains values 2 and 3. Let's say it is at memory location 819. So you will just have the address 819 stored here. Just like nested list and nested tuples, we have nested if we have a list or a tuple or a dictionary inside a dictionary, this is how it is managed in address. Even if you have another dictionary, that will be stored in some other memory address and you will have a pointer. Okay, so this is how it will be stored. Now we are saying D2 is equal to D1. So what does this statement do? This will not create any copy at all, right? This will just create a pointer assignment or reference assignment. It will just assign reference or pointer or address. It means that now D2 will also be pointing at the same memory location which D1 is pointing at. No copy will be created here. If you write D2 of A is 2, so D2 is pointing at this dictionary, D2 of A is 2, which means this value will be updated to 2. And now we are saying D2 of B dot append 4. D2 of B is this list. And we are saying append 4 to this list. So 4 will be appended to this list. Now if you print D1, even though we made changes to D2, if you print D1, they both are pointing to the same memory location. When you print D1, you will see output as A2 and B234. Okay. So this is how assignment or like assignment copy will be there. Like if you just do assignment, there will be no copy created. Now we have copy function for dictionaries, just like list. There are two ways to create shallow copy. In list, we have seen there are two ways to create shallow copy. One is using directly on any list, you can use the dot copy function, and other you can use the copy library and copy of list. And both of them are available for dictionaries as well. For tuple, dot copy function is not available. We have seen that. For tuple only this is there. But for dictionaries, copy function is also there and copy library is anyways there. Okay. So you can create shallow copy using dot copy function or copy. So here what we are doing, again let's see memory, how will this be happening. Again same memory is there, so we have in memory what will happen. Let's say at memory location 756, D1 variable is pointing here, it is a dictionary containing key and value pairs. For string A the value is 1 and for string B there is a list. So list will be stored somewhere else in memory at let's say memory location 819, and you will just have an address stored here and it contains values 2 and 3. Now when you say D2 is equal to D1 dot copy, it will create a shallow copy. It will create a shallow copy. So if you used copy.copy function or .copy function of the dictionary directly, it will only create a shallow copy. So what does shallow copy mean? Only the outer structure will be copied. Only this dictionary will be copied. The inner list or inner dictionary or inner tuple, whatever inner elements are there, their copy will not be created. So if you do this, d1.copy, another dictionary will be created as it is. Just a copy of this will be created. Another dictionary, key, value, and d2 will be pointing here. Let's say at memory location 973, and string A, string B. String A has value 1 and string B again has the exact same pointer, 819 will be copied, so it will also be pointing here. So this is what shallow copy means, right? Now if you say d2 of A is 2, which means d2 of A is this, so this will be updated to 2, and d2 of B dot append 4, which means d2 dot B dot append 4, here 4 will be appended. So here the value of A is a different copy. A is not changed in d1 because that was a static value. But if you have another collection inside the dictionary, that will be same. So what will happen if you print d1 now? A will be 1 only, but B value will be changed. It will be 2, 3, 4 because it was pointing to a list. And that is why if you print d1 now, you will see A as 1 only, but B will be 2, 3, 4. Okay, this will be the output. And this is how shallow copy works. Only the outer dictionary is copied. So if you have a value which is like integer or like floating point value or complex number or boolean, that will be copied. But if you have a list or tuple, any collection, that will not be copied because that will be present in another memory address. Okay. So that is how it is done. This is what shallow copy means. So always be mindful, if you want to copy the inner list as well, you have to use deep copy function that is available in the copy library. Firstly, you will have to import copy. Then you can write copy.deepcopy of d1. So here what will happen? Memory location 756, key and value, string A value 1, string B value is a list containing elements 2 and 3. Let's say at memory location 819, d1 variable is pointing here. Now when you write copy.deepcopy of d1, a deep copy will be created, which means all the inner elements. You can have a list, inside a list you can have another dictionary, whatever is there. Any number of inner elements you have, a copy of everything will be created in memory. So deep copy means another dictionary will be created, another list will be created. Let's say at memory location 537, this is at memory location 913, and d2 will be pointing here. You will have key and value, A will have value 1, and B will be pointing to this new list that we created. That will again have elements 2 and 3. This is how deep copy works. So now if you say d2 of A is 2, this element will be changed to 2. And if you say d2 of B dot append 4, 4 will be appended in this list. Now d1 remains unchanged. This remains unchanged if you create a deep copy. So now if you print d1 again, the same values will be printed a1 and b2, 3. It will be unchanged. So always be mindful, if you want to create a deep copy, use copy.deepcopy. If you use the copy function, only the outer dictionary will be copied. Okay. Okay, now let's look at the default dict. What is default dict in Python? So default dict is a subclass of the built-in dict class. I told you every data type is a class in Python. What is a subclass? That we will see in object-oriented programming lecture. So what happens is default dict is also created, and it is created to fix one major flaw which was there in dictionaries, and it is a subclass of dictionary, which means all the functionality which are there in dictionary is also there in default dict. But there is one added advantage that we have, and the added advantage is you will have default values. Okay. So firstly, how to use default dict, I will tell you what the advantage is. Firstly, how to use it, you can import it. You have to import it. It is not a default data type. It is present in a library. So it is present in collections library. So you have to write this statement first before using default dict. You have to write from collections import default dict. So the default dict class will be now imported in your code. Okay, before using default dict, you have to import this class. And this class is present in collections library. So you have to write from collections import default dict. Now we can use default dict. Now what is the motivation behind using default dict? So what happens if you create a normal dictionary, if you create a normal empty dictionary, if you write d of a plus equal to 1. So what we are doing here is, we have an empty dictionary and we are saying d of a. D of a means what? It is like saying whatever value is present at the key A, you increment it by 1 plus equal to 1. See, if you have just written equal to 1, then it is okay. Why? Because here what we are saying, you are assigning the value to this key. But we are not saying this, we are saying plus equal to 1. It means that this statement is equivalent of writing d of a is equal to d of a plus 1. Now when you write this statement, d of a doesn't exist. So we cannot check the value of d of a because this key doesn't exist. Here we are doing indexing and this key does not exist and you will get an error. Now why will we write this piece of code, you might ask? Why will we increment a value? So this is a standard way in which we can count how many times an element is present. So let us try to write that code, okay? Let us say we have a string banana. And I want to count, see this is an iterable, string is an iterable that will take values B, A, N, A, N, A. I want to count how many times every character is present in this string. So let us try to write a code. Let us say the count is a dictionary like this, empty dictionary. And now I'm saying for every character in this string banana, let's say this is present in the string S. So for every character, for char in S, which char will take B, then A, then N, then A, then N, then A, these values. What will I do? I will say C of char plus equal to 1. Right? Whatever was the count of this character in the dictionary before. So in the dictionary I just want to store, so this is the dictionary now in memory. Let's set memory location 756 and the C is pointing here. This is the count of every character, okay? And here we will have key and value. So right now it is empty. So firstly, when char will take value B, we are saying that just increase the count of character B in the dictionary, but B does not exist. Right? So we have to write the code like this. In that case, we will have to write the code like this. If char in C, so which means that if this character is present as a key in the dictionary, then I can increment the count directly. Then I can say C of char plus equal to 1. Otherwise, if the character is not present, then we will have to add it. Then we will have to add the count as 1 because previously it was not present. But now we encountered it once. It means that I have to initialize it with 1. So I will have to say C of char is equal to 1, which means that, so firstly what will happen when the char will take the value B. B is not in the dictionary right now. So we will go in else. So this will be false since B is not a key. I told you, right, by default if you write the dictionary name, you will only see keys. So you can check that a particular key is present in a dictionary or not like this. So it will be false. So you will come out, else will be executed. And we will say that C of now char is what? B. So C of B will be equal to 1. So now we are adding a value. For B, we are adding the value 1. Now similarly, now char will become A. A is also not present in the dictionary. So we will just add its value. A is also right now present 1 time. Now N will come. N is still not present in the dictionary. So we will go in else and we will say N is also present 1 time. Now char will become A. A is already in the dictionary. A is already in the dictionary, which means we have already seen it at least once. So now we will see C of char plus equal to 1, which means you just increment its count by 1. So C of char means C of A, character A. Character A already exists. So now instead of 1, it will become 2. Okay, now again N will come. N again already exists. So its count will also be incremented. Now again it will become A. A already exists. So its count will be incremented to 3. So now the dictionary contains B1, A3 and N2. So this is the code that you have to write using normal dictionary. This is using normal dictionary. If you want to count how many times every element is present in a collection, in any collection, you can have any iterable like string or a list. In a list, let's say I want to count how many times every element is present, same code will work. But here the problem was we did not have default value. Every key is not present by default, right? And for this use case, for things like this, we have created a structure called default dict. Now what default dict does, in default dict we can say that default dict is like a normal dictionary only. It is like a normal dictionary, but it is default dict, which means it will have a default data type for values. It will have a default data type for value. So let's say I am creating a default dict of type integers. It means that all the values will be integers. Values will be integers, and default value of integer will be taken as 0. So what will happen, for every key, if it is not present, an entry will be created with the value 0. For any key, if it is not present, it will think that the value is 0 by default. So if you are creating an empty default dictionary, let's say its name is D. Now if I say what is D of 1, D of let's say A, although A as a key is not present here, but if the key is not present, the default value will be taken as the default value of the data type, which is, so here we created a default dictionary of integers, and default value of integer will be taken as 0, and hence it will automatically give the value 0. See, in a normal dictionary, if you say what is D of A, if A is not present, it will give you error. But in a default dict of integers, if a key is not present, you will always get the value as 0. So if you create a default dict like this, named D, so here we don't have to write this if else condition. Here we can directly write for character in string S, I can directly say D of char plus equal to 1. Why? Because even if the character is not present, its value will be taken as 0. You will not get any error while indexing. So if the default value is 0, automatically when B comes, the character B comes, its value is by default 0. So it will be incremented by 1, so it will become 1. And similarly, at the end of the day, all the characters will have their correct values. We don't have to write if else. So every key will have a default value in default dict. That's how default dict works. Okay. So this will give a key error because D of A doesn't exist. A as a key does not exist. But if we use default dict, let's see what happens. So how to create a default dict? From collections, import default dict. Now when you have imported default dict becomes a constructor now, simple constructor. So here you can say D is now a default dict of type integers, which means all the values will have a default value integer. You can add some other value also. If you want, you can write D of A is equal to string hello. That is okay. But if there is no value present, let's say if you want to print D of B. Now B as a key is not present in the dictionary. B as a key is not present in the dictionary. So you will automatically see the value as 0 because default is integer and default value of integer will be taken as 0. Okay. So you can directly write D of A plus equal to 1. You will not get any key error. It will automatically initialize A with 0 and it will increment its value by 1. So now D of A will become 1. Okay. So syntax is very simple, default dict, and in the bracket you have to give a default factory, which means you have to give a data type. Consider factory as a data type right now. We will see later in advanced concepts what factories are. But for now you can consider them as data types. You have to just give integer or str or tuple like classes, right? So it provides default values when a key is missing. If a key is missing, it will give you default value for that particular data type. So what are the data types that you can give in default dict? These are the default values written by commonly used callables in default dict. So these are the data types that you can use: int, float, string, list, set, dict, bool, tuple, any data type that we have seen. So the default value that will be used is for integer 0, for floating point value 0.0, for a string empty string, for a list empty list, for a set empty set, for a dictionary empty dictionary, for boolean false value will be there by default, for tuple empty tuple, and you can create a custom callable as well. Custom callable means creating your own default function. So when we see functions, we will see how to create callables and all that. Right now you can skip this. You can add data types basically, okay, like this. And if you don't want default data types, you can create your own data type by creating a callable as well, okay. So let us see an example. Here we are saying dint is default dict of type int, which means dint is a variable that is pointing in memory to a default dict. of type integer, which means default value will be 0 if key is not present. It will never give you a key error. Okay, so if you print d or int of x, right now there is no value of x. You have not added any value with the key x. So by default the value will be given as 0. Similarly, if you create a default dict of list and if you print d list of y, this key is not present, so you will get an empty list as the output. And if you create a default dict of strings and if you print d str of z, z as a key is not present in this dictionary, so you will get the answer as empty string. So empty list, empty tuple, empty string or 0 values will be given by default. Okay, and this is very helpful when you are solving graph problems, DP problems, right? Because you don't want to check anytime. Every time you don't want to check. What happens is, generally if you are creating an adjacency list for a graph, you just want to add, if a new information came in, that this node is now connected to this node. Node 1 is connected to node 2. Okay, let's say undirected graph. We will see it in DSA, don't worry about it right now. So if node 1 is connected to node 2, this new information came in. Then you don't want to check in dictionary that node 1 is present or not. You just want to directly say d1.append 2, directly like this. You will create a list d1.append 2. So even if 1 as a key is not present, an empty list will be created and 2 will be appended in that. So you don't want to check every time, and that's where default dict helps you. So this is what default dict is. Next is counter. What is counter? Counter is again a library in Python. So they are all subclasses of dictionary, like they are all dictionaries only, okay? Default dict and counter. Counter is again a subclass of dict in the collections module. So in collections module we had default dict. In collections module only we have counter as well. But note that default dict had a small d. Like this is how we were rewriting it. But in counter we have capital C. Okay, so the counter class is created like this. Here we have capital C. So from collections import counter, this is how you import it. Now how to use it? So what it does is, I gave you a piece of code, right? This piece of code. This is what exactly counter does. It will just count. This is the dictionary that counter will create automatically. For any iterable, if you want to count how many times every value is present in that iterable, counter library can create that dictionary by default for you. Okay, if you don't want to write this piece of code again and again, if you just want to count for any iterable how many times every element is present, this dictionary basically, how many times every element is present in that iterable, it can be created. This dictionary can be directly created by using counter library. So how does it work? You can directly say C is equal to counter, and in the constructor, while you are using the counter constructor, you can directly give any iterable to it. You can give any iterable to it. Basically, iterable means a list, tuple, another dictionary, or you can give it anything basically, right? Like a set, okay, or a string or the range function, okay? So any iterable you can give, and inside that iterable, it will just count how many times every unique element is present. So when you print this C, directly the output will be a counter type. It will be a counter type. Counter is just a dictionary, okay? You can convert it into a dictionary as well. You can actually do like this. If you don't want counter type object, if you want to convert it into dictionary, you can do like this. A counter object can be converted to a dictionary because counter is also a key value pair. Counter is dictionary only basically, okay? And it works exactly the same. So even for C, you can say what is C of A, C of N, C of B, everything. So it is also a dictionary, but it is not exactly a dictionary, it's a subclass. So it creates a counter type object, and if you want, you can convert it into a dictionary by wrapping it with dict. So the output will be A3, N2 and B1. So it will automatically count how many times every element is present, and it will return that. It counts how many times each unique element is present in the iterable, and that's how you can use counter, okay? So this is what, like, a few specialized libraries that are created over dicts, default dict and counter in Python. Now let's see some examples. What will be the output of the following code? We have a dictionary D containing A1, 2B and 3C. You have to print d.get4 and default value is not found. So this is how the get function works. In the get function, you can give a key and a default value. So it never gives you an error. The get function never gives you an error. Even if the key is not present, it will just give you the default value. And if the default value is not given, then the default value of default value is none. So none will be given as output. Error will never be there. So here what is happening? 4 is not present as a key in the dictionary. So you will get the default value as the output. So the string not found will be given as the output. So the output will be not found, which is option B. If the default value was not given, then none will be the output. Okay. But key error will never be there. If you use like this, if you print D of 4 directly like this, then you will get a key error. Okay. But here the answer will be not found. This is the next question. Which of the following types can be used as keys in a Python dictionary? I told you like keys in a Python dictionary must be hashable. And hence they must be immutable. And every element inside them must also be immutable. Okay, then only it will be hashable. So list, can we use a list as a key? List cannot be used because list is mutable and hence it is unhashable. It must be immutable. Tuple is immutable, so tuple can be used. Set is mutable, so set cannot be used. Dictionary is mutable, so dictionary also cannot be used. Only tuple is immutable and hence tuple can be used. So option B is correct here. Only option B, okay? Next, how many key value pairs will be present after the following code is executed? So we have created an empty dictionary here. D is an empty dictionary. And we have said D of true is equal to 1. So here is a very important concept. This is an advanced level concept. You can skip this question if you want. In the demo, we will see that. I told you, right? Every dictionary, when it is stored in memory, how it happens, if you are storing a dictionary, key value pairs will be stored. Okay. Let's say at memory location 756 and the variable is pointing here. So keys are not present directly. So the hash values of keys are present. Keys are not present directly. Firstly, hash is computed and that is why keys must be hashable. Why do we calculate the hash value? That we will see in hashing. Because hashing makes access very fast. And that is why for any key, hash value will be calculated. Okay. So, and hash value is calculated using the hash function which is given in Python. Okay. And hash function internally works like that. Like it's a feature of hash function. In the demo, we will see this. For all the hash value of 1 will be actually equal to the hash value of 1.0. And it will be equal to the hash value of true. Because true internally is 1 only and 1.0 is also the integer 1. They are equal. Because 1 and 1.0 are equal and true and 1 are also equal. And that is why 1, 1.0 and true, all of them will have the same hash value. We will try to run this and see. Hash value of all of them will be actually equal to 1 only. Similarly, the hash value of 0 will be equal to hash value of 0.0 will be equal to the hash value of false. And actually it will also be equal to the hash value of an empty string. It will be equal to the hash value of an empty list. And it will be equal to the hash value of empty tuple and so on. They will all be 0 only. So internally they are implemented like this. And that is why in a set if you are inserting false and 0 and an empty list and an empty string, nothing will happen. A single element will be present, 0 or false, any one of them. And because order doesn't matter, only a single element will be present. Okay. In a set, because also in a set elements are firstly hashed and the hash values are stored. And that is why inside a set elements must be hashable. Okay. And this is a concept that in the demo we will try to see like what values have equal hash values. This is not important as coming to exams. This is an advanced concept. But this is like for your information, you should know that. Like if you know it, it is better. So like this is how it is done. And that is why here what is happening, D of true is 1. So key will be true. True is nothing but the hash value of true is 1 only. The hash value of true is 1 only. So the hash value will be 1 and the value will be 1. Now when you write D of 1 is 2. Now again the hash value of 1 is also 1. So again same value will be now overwritten to 2. And hash value of 1.0 is also 1. So again again the same key, the value will be updated to 3. You might think that these 3 are different, but they are not different for a dictionary key. And they are also not different for a set element. If you insert all these 3 in a set, you will have only a single element 1 because of the hash values. Okay, again it's an advanced concept, but after the end of this statement, if you print the length of the dictionary, there is only a single key value pair present and the answer will be 1. We will try to run this and see how it works, but this is a concept of hash functions in Python. Okay, so the answer will be 1. So these are a few examples on dictionaries. Now here we have hands-on exercise on dictionary. So again, as every lecture, try to solve them first on your own. Try to write Python codes for these exercises on dictionaries. And if you're not able to do it, we will see some of them in the demos, in the demo which is coming next. And this is all about dictionary data type in Python and what are the different methods which are available in dictionaries. What are the different operations that you can do. Now let's see a demo on dictionary in Python.
Okay, now let's see a demo on dictionary in Python. So we will start with creating dictionaries. So again, dictionaries like sets are created using curly brackets, and you can create an empty dictionary just by creating empty brackets. Empty brackets, curly brackets are considered as empty dictionary only. They are not considered as set. Okay. So if I print D and if I print the type of D and if I print the length of D, it will give me an empty dictionary. It is of type dict and the length is 0, which means there are no elements inside it. So this is how you can create dictionary using curly brackets. And if you want to add some elements in dictionary, you add elements by giving key colon value pairs. So let us say I say that for key A, the value is 1. Okay. And I again print all these things. So we can do that. And now it contains a single element, so length is 1, not 2, length is 1 because it contains a single key value pair. For key A, the value is 1, and you can have multiple such combinations for key value pairs as well. So let's say we have for A we have value 1, for B we have value 2, and for C let's say we have the value 3, and so on. So here I am creating strings. The keys are strings and the values are integers, and that is allowed. And you can have any type of keys like key value pairs. It is heterogeneous, so keys can be of any type, values can be of any type. It's just that keys should be hashable, and we already know what hashable means, right? We have seen that in set lecture. So let's say for the first one, the key is a tuple and the value is a list. Value can be mutable. Value need not be hashable. Value can be anything. And let's say for second one, the key is the string hello and the value is a set containing elements 3, 4 and 5. And for the third one, the key is a boolean value, and the key is the boolean value and value is a complex number, let's say. You can have this type of dictionary as well. So if I print D here, this is the dictionary that we have, and this dictionary will have length of 3 because it has 3 key value pairs. Okay, so this is how you can create dictionaries. Now let us see how we can create dictionaries using the dict constructor. So just like every other collection, we have a dict constructor. If you want to create an empty dictionary, you can just not pass anything inside the constructor and it will create an empty dictionary for you. If I print empty dict, it will be just an empty dictionary. Okay, its length will be 0 and its type will be dictionary again. And you can also give it some values here itself. So you can say that D is a dictionary and the key is name and the value is, let's say, John, and let's say the age is 30. So we can create dictionaries like this as well. So if I print D now, again it will be a dictionary with key name and value John and key age and value 30. And also in the dict constructor, you can pass an iterable of tuples. An iterable of tuples, and for every tuple, the first value will be taken as key and the second value will be taken as the value. So let's say if I do dict of, and if I pass a list, or you can pass a set as well, or any iterable basically, but it should contain tuples. So it contains, let's say, 3 tuples. And in the first tuple, I am saying the key is name and the value is John. And you can create strings using single quotes or double quotes, whatever you like. And for the second one, let's say age, the value is 30. So this is how I'm creating tuples. And let's say anything, score is, let's say, 45. So this is what this is how you can create a dictionary. Again, if you print D, it will be a dictionary containing these 3 key value pairs. Okay, so this is how you can use the dict constructor. And in the dict constructor there is also a from keys method, and if you want to populate a dictionary with multiple keys but with the same value, you can use the from keys method as well. So let's say if you have some keys present in a list or any iterable, again it can be any iterable. So let's say the keys are A, B, C and D, and you want to create a dictionary with all these keys and with the same value. So if I write dict dot from keys, and here I just have to pass all the keys and the value which I want for all of them. Let's say the value which I want is the number 0. Then I can do that, and now if I print D, a dictionary will be created with key as A and B and C and D, and all of them will have a value of 0, 0, 0, 0. So these are the different ways in which you can create dictionaries in Python. Now let's move to accessing and looping over dictionary elements. So firstly, how do we access elements in a dictionary? We can access elements not by index. Although dictionaries are ordered after Python 3.7, dictionaries are ordered, but still you cannot access them via index. They don't have indices. You can access the value using the key. That's what you can do. So again, let's say we have this dictionary. Let's take this dictionary only. Okay. So here we have key name and John, value John, key age and value 30, and key score and value 45. So I can print D of name. It will give me the name of whatever value is present corresponding to that key, and let's print the age and let's print the score. Okay. So this is what something we can do. And remember that if you're giving a key which does not exist, then it will give you an error. You should only give keys which do exist inside the dictionary, and then only you can access the elements. Now we can access it using the get method as well. It will do the same thing. Again, in the get function, you can give any key and it will give you the value corresponding to that key. So let me create this dictionary in a better way so that it's more readable. Let's use curly brackets only. So cool. So this is the key, this is the value, this is the key, this is the value, and this is the key, and this is the value. Okay. And let us use this example only for all our use cases. Now get function also works the same way. So if I do print d dot get of any key, let's say name, again it will work the exactly same way. Here also you have to make sure that key exists. If the key does not exist, again you will get an error. So you can print everything using the get function as well. Now if you want to get all the keys of a dictionary, you just want to print all the keys of a dictionary, you can just say d dot keys. This will give you all the keys in the dictionary, and it gives an object of type dict keys, which is an iterable. It does not give you a list. It is an object of type dict keys. But if you want, you can convert it into a list or something. Because it is an iterable, you can convert it into anything like set or tuple or list you want, right? Because you can pass it to the constructor and it will convert it. So it will just give you a list of all the keys which are present in the dictionary. Now if you want to iterate it, you can iterate over it like using a for loop or whatever you want. So let's first print it directly, and then we will iterate over it as well. So now let's iterate over all the keys. So for key in d dot keys, let's print the key. So this particular loop will print all the keys in the dictionary. And you don't need the keys function. Generally people don't use the keys function because dictionary's name also does the same job. If you do print d, then it doesn't. If you print the dictionary itself, you have to print the entire dictionary. But if you can use the name of the dictionary as an iterator on keys. You can use the name of the dictionary as an iterable on its keys. So what I'm trying to say is you can directly say that for key in d. D means like I'm just using the name of the dictionary. It is automatically an iterable on its keys. So this will also give you the same thing. Okay, this will also print all the keys which are present inside the dictionary itself. Okay. This was about keys. Now let's look at values. So same way we can print the values which are present in a dictionary as well. So if I do print d dot values, it will print all the values. It gives you an object of type dict values, which is again an iterable. You can convert it into anything else if you want. And if you want to iterate over all the values in a dictionary, See here, the variable name doesn't matter. I'm just keeping it meaningful so that like when you read the code, you know that it is a key. But you can have anything XYZ here, doesn't matter, right? It is just the name of a variable. So for value in d dot values, I can print the value and it will print all the values in the dictionary in that order. And yeah, that's about the value. And another way of printing all the values is we can get the value from the keys also. So what I can do is I can say that for key in D, which means key is in the dictionary keys, I can directly print student or D. D is the name of dictionary. D of K. D of K means what? The value corresponding to the K key in the dictionary, right? And that also gives you the values only. So this is another way of printing values, but yeah, we can use the values method as well. Next is items. Items gives an iterable on tuples. Items gives you an iterable on tuples. So if I print d dot items, it will give you an iterable on tuples. Iterable of type dict items. Again, you can convert it into a list if you want. So it is an iterable on tuples. Tuple means first element is key value pair, then also key value pair and key value pair. And we already know tuple packing, unpacking. So I can directly write for key comma value in d dot items. Here k will take the key and v will take the value because tuple will unpack. So now you can print key and value both for all the items. And another way of doing it is you can iterate over all the keys also. So for k in d, you can just directly print the k key and you can print the value like d of k because you can get the value using the key always. So this will also do the same job for you. Okay, so this is how you can do it. Like these are the multiple ways of iterating over all the elements of a dictionary. Now let's look at operations on a dictionary, like what operations are present. First is size of dictionary, very simple. It just gives you how many elements are present in a dictionary. Let me take the same dictionary again. How many elements means how many key value pairs are present. So again, len function does the job for us. It will just give us how many elements are present. Now adding entries into a dictionary, that is very simple, that you can directly do using indexing. You can directly do it using indexing. Let's say you have a dictionary that contains A1 and B2. Now now you want to add one more element, one more key value pair C3. So you can directly say D of C is equal to 3. So if this particular key is present, it will update the value, and if this key is not present, it will add the key value pair both. So this is like the most amazing statement in dictionary. You can directly like add value, and if you want, you can update it as well. So the same syntax works for updating values as well. So what I mean to say is, let's say in the same dictionary now C3 is added, but you want to change an entry. Let's say for the value for A is something that you want to change. The value of A is something that you want to change to 100. Then directly you can do this. And since the key was already present, its value will be updated now. Now if you print the dictionary, you will have A100, B2 and C3. So the value is changed. And there is another function to update values. If you want to update multiple values, then we can use the update function. So let's say in the same dictionary, like this is the dictionary right now, A100, B2 and C3. I want to add a few key value pairs. And what it will do, again, it will do the same thing. If the key is already present, it will just update the value, and if the key is not present, it will add the key value pair. So let's make the value for A 100, that is already 100 anyway. Let's make the value of B 200, and let's make the value of D as 400. So it will change the values of A and B, and it will add D as well. So when you do this, and after this, if you print the dictionary, A will be 100, B will be 200, C will still be 3 because we did not change C, and D will be 400. Okay, so this is how you can update multiple entries in a dictionary. Now let's look at deleting entries in a from a dictionary. So again, if I take the same dictionary, let's say this one, let's add one more C3. Now if I have to delete a particular key value pair, I can use the del keyword. I can write del of A. So then the key value pair corresponding to A will be deleted. And if you print D now, the key value pair corresponding to this key A will be deleted. Now if this key is not present, then it will give you an error. Again, you have to make sure that that particular key is present inside the dictionary, then only it will work. And another way of doing the same thing is using the pop function. So you can also say that d dot pop of a. You can also say d dot pop of a. So that also does the same thing. It also deletes that particular key value pair. Pop function or del keyword works the same way. And there is another function called pop item. Pop item deletes the last key value pair which was inserted. Pop item. Here in dictionary, always the item represents the key value pair. That's why when you say dot items, you will get key value pairs. So when you do pop item, it will delete the last key value pair which was inserted. So here C will be deleted because this was the last which was inserted. Okay. And if you want to delete all the items in the dictionary, again, let's take the same dictionary, and if you want to delete all the items and if you want to clear the dictionary completely, you can use the clear function. It will make the dictionary empty. So in all mutable collections, clear function is present because dictionaries are also mutable. You can change the values or keys if you want, and hence in all mutable collections you will have clear functions because that will just make the collection empty. In string you don't have clear function because that is immutable. In list you have clear function because that will make the list empty. In tuple you don't have clear function because tuples are immutable. In set you have clear function because that is mutable, and in dictionary you have clear function. You can remember it that way. Okay. So this is about deleting entries from a dictionary. Now let's look at sorting a dictionary. So sorted function works on any iterable. So if you want to sort the keys, you can sort the keys. We already know how to get the keys and how to get the values and how to get both key value pairs. So let us say we have a dictionary like this, C3 and A1, then D4 and then B2. This is our dictionary. Now if I print D, it will print the entire dictionary. But if I print sorted of D, so sorted function takes an iterable, and I told you that the name of the dictionary is an iterable over its keys. So I'll just get all the keys in a sorted way, in a list. Sorted function always gives you a list. So if you want the list of all the keys in a sorted way, you can use directly sorted of D. And if you want, you can use d dot keys as well. That will also do the same thing. That is also an iterable over the keys, so they both will work the exact same way. And if you give it an iterable over the values, it will sort all the values and you will get a list of all the values in a sorted manner. And similarly, if you give it d dot items, the items gives an iterable over the tuples. Items gives us a iterable over the tuple, which means key value pair in a tuple. So it will just sort that tuple, basically the list of tuples. So you'll get a list of tuple in a sorted way. So and if you want to convert this thing again, this list of tuples into a dictionary, that you can do, that you can use using the dict constructor. So sorted dictionary is something that I want to create, and so if I have to do that, I can directly pass the output of this entire thing, which is a list of tuples, into the dict constructor. I already know it will convert it into a dictionary. So if I print the sorted dictionary now, I'll get the sorted dictionary out of it, which means it will have firstly sorted on keys, and if keys are same, actually keys cannot be same. In a dictionary, keys can never be same. They will always be unique because when you try to add, it will update the value. You can never add the same key twice. So keys will be unique. Cool. So this is how you can sort dictionaries in Python. Now let's look at hashability of keys. So whenever you have unique items, generally they are using hash values. Sets always have unique items, and that's why it uses hash values. And again, the key of a dictionary also uses hash values to store them, and hence that's why they should be hashable. And that is why immutable objects can only be the keys of a dictionary. Mutable objects cannot. You cannot have a list or a set or another dictionary as a key of a dictionary, because dictionary is mutable and list is mutable and set is mutable, and these three cannot be used as the key of a dictionary. Even if a tuple contains another list, that makes it mutable. Tuple is immutable, but the object inside it is mutable, and that's also not hashable. We have seen that in set lecture, and that also cannot be used as a key of a dictionary. But all immutable objects can be. So let's say a tuple can be used as a tuple can be used as a key because it is immutable, and again a string also can be. String can be used as a key, but value can be anything. Value can be a list also. doesn't matter, right? And all what else, like you can have boolean values also as keys, and let's say value is a complex number here. So this is allowed because they are all hashable. They are all hashable, a tuple, a string, and this thing. But we know that if a tuple contains another mutable object, then it will not be hashable. So I cannot have this like as a key, a tuple containing a list, and let's say another integer. This cannot be a key now, because now inside this tuple you have a list, and that makes it unhashable. Even you cannot have a set. Sets are definitely not allowed to be keys because sets are unhashable. But frozen sets can be a key. And even dictionaries cannot be key. A dictionary cannot be a key for another dictionary because dictionaries are unhashable, right? So a dictionary cannot be a key for another dictionary, but a dictionary can be a value for another dictionary, and that is what we call a nested dictionary. So the next concept that we cover is nested dictionaries. Okay, now let's look at nested dictionaries. Again, reiterating the concept that a dictionary key cannot be another dictionary because it is unhashable, but a dictionary value can be a dictionary, and hence you can only have nested dictionaries in the form of value being a dictionary, not key. So let's say I'm trying to create a dictionary now. Okay, so let's say for a student, let's make it a student. For a student, the name is Alice, and let's talk about marks. Now, marks can be another dictionary because I want to actually store the marks of different subjects. So the value for marks is now another dictionary. And see the beautiful indentation the collab already does for me. So it is very helpful. Now, marks, let's say, is another dictionary where I'm storing math marks, math, let's say this code 85. And I'm taking the same example that we discussed in class, and in science, let's say they scored 90. Okay, and now let's say I add address of this student. Address is another dictionary. Now in address I am going to store city, and let's say they live in Hyderabad, and let's say I'm storing the pin code, and in pin code I'm storing the pin code whatever, like 50001. So this is a nested dictionary because it contains another dictionary as a sorry, I forgot a comma, as a part of value for certain key. So if I print student now, it will be a dictionary. It is a valid dictionary, and it will print like key value, key value, key value pair, and some of the values are dictionaries themselves. Now, how do I index elements here? So if I print student of name, that is easy. That is an easy problem. It will just print the value corresponding to the key name, which is Alice. But if I print student marks, now the value corresponding to marks is another dictionary. So the entire dictionary will be printed. And similarly, if I print student address, address is another dictionary. The value is another dictionary. So that dictionary will be completely printed. Now, if you want to index these dictionaries themselves, you can add another bracket. So what I'm trying to say is, like, I can say that print student marks, and since this is a dictionary, I'll add another level of indexing, and I'll say what are the marks in math. So it will just print the marks in maths. And similarly, what are the marks in science? And similarly, let's say I want to print student address, and inside the address I want to print the city. I can do that. And lastly, we have address may we have pin code. So I can print all these values separately because they are themselves dictionaries, and this is how nested dictionaries work in Python. And all these dictionaries are mutable. You can make changes to any one of them, whatever you want, you can do that. So later, like tomorrow, if we want to add another marks in another subject as well, so I can say student marks. Let's say I want to add marks in biology. So science is already there. Let's make it English. In English, let's say the students secured 45 marks. I can do that. Now this entry will be added if I print student again. Now this particular entry will be added in this value. So now math is 85, science is 90, and English is 45. So we can do all sorts of things like this. Okay, so you can have nested dictionaries created like this. Now dictionary comprehension. So all mutable structures have comprehension present. So I can create dictionaries, but I'll have to give key value pairs here. So I can say that for, let's say, if I say key in for, let's say, key comma value in a list of tuples, I can do that, because this list of tuples, now every tuple will unpack to k comma v, and this will be populated in k and v. I don't need to do all this. If I had list of tuples, I can directly use the dict constructor, but again, like, this is another way of doing it. Let's say a comma 1 and b comma 2 and let's say c comma 3. So we can do things like this. Okay, so this will create a dictionary. So dictionary comprehension is also possible. And another example which we saw in class was, let's say, for every value I want the value to be the key and the square of the value to be the value. So I can say like something like this, and if I can say if n is in range, let's say 1 to 10. So this will create another dictionary where key is a value from 1 to 9 and values will be their squares. So we can do things of this sort using dictionary comprehension in Python. Now let's move to the concept of dictionary copying, which means we can actually copy dictionaries as well. So let me create a dictionary D1 with key A and value 1, and key B and value is a list containing 2 comma 3. Why am I taking a list? Because in shallow copy that list is not copied, instead the address is only copied. So if I say D2 is equal to D1, that is not copying at all, that is just a pointer assignment. They both will be pointing to the same address. If you want to prove it, you can print the ID of D1 and the ID of D2. So you will see that they are actually pointing to the same memory address. So if you make changes in one of them, another one will also change. So if I say, let's say now say D2 of A should be equal to, not equal to 1, let's say it should be equal to 200. And similarly, if I say D2 of B is also changing, I'm appending another value to it. It's already 2 comma 3, I'm appending value 500 to it as well. So if I print a D1 now and D2 now, both will change because I did not make a copy, I just did address assignment. So you can see they actually point to exact same address and both are changed. Now another way is you can make a shallow copy. So dictionaries do have dot copy function. If I say dot copy, it will create a shallow copy. And another way of doing shallow copy is copy.copy function if you import copy library, right? So in shallow copy, what will happen? They will actually point to different memory locations, and hence when you made the changes in D2 of A, because since it was not a nested structure, it was just a value, that value changed in D2 but not in D1 because they were pointing to different memory locations. But coming to the list, because for the value for B was a list, and if you have a nested structure, another list or another dictionary or another set present inside it, that value will not be, like, the memory address will be copied and not another structure will be created, and hence for both of them it changed coming to this list. And if you want to proof of this as well, you can actually print the ID of D2 of B and D2 of D1 of B and D2 of B. We just want to see where do actually like they reside. So okay, yeah, sorry, it will take only one argument. So D1 of B and the ID of D2 of B. So these two IDs are exactly same, which means the address got copied. Both the lists are pointing to the same list. Actually, both the addresses are pointing to the same list. The address got copied. Here the value got copied 1 and 1, and that value changed. But here the address got copied and hence list changed. We have seen this concept in class. Now, if you do instead, like in the same example, instead of shallow copy, if you do a deep copy, this problem will not have come. So if you want to make a deep copy, you have to import the copy library. So if I import the copy library, now I can use copy.deep copy function, copy.deep copy of D1. Now the addresses of all the inside structures will change. Even like D1 of B and D2 of B have different addresses. D1 and D2 also have different addresses, and changes in D2 did not affect D1. It's completely fine. So always whenever you have nested structures, you have to make a deep copy to make it work. Cool. Now let's look at default dict. what does default dict do? It will give some default value to every key. Even if the key is not present, it will always have some default value. Okay, without even adding it, whenever you're trying to access it, it will always have some default value. So let's say we have a dictionary containing elements A1 and B2. Here if I print D of A, that will work fine. Print D of B, that will work fine. But when I do print D of C, that will not work because C as a key does not exist in this dictionary. And it is sometimes very important that you want, for any possible key, you want a default value. Even if the value is not present, you want some default value, because you don't want to add all possible keys beforehand. You will later at some point in time know that some more keys are coming and you don't want to add them like again and again. You just want to directly change them. This thing will be very important in competitive programming. Okay, when we see DSA graphs, when we will always create graphs using default dict. Okay, so we don't want to create like all the nodes beforehand. On the fly, when new nodes come, I don't want to populate it in the dictionary. I want some default value to be present, empty list or empty something. So what you can do is you can create a default dict instead, and there this problem won't come. So to use default dict, you have to import it from collections library. So from collections, you can do import default dict. Now default dict is present in your compiler. So now you can say D is equal to default dict. And in default dict, you have to just say what default value do you want for every value. And it will always give you default values for different data types. So if you write int, it is a default dict of integers and the default value will be 0. And similarly, if you write string, it will be an empty string. If you write list, it will be an empty list, and so on. So now if you even if you say d of a is equal to, let's say, 1, even if you say d of b is equal to 2, so you are populating the values for a and b. But instead, like here, if you print the values of d of a, b and c, a and b is something that you populated and c is something you did not populate. So c is not present in the dictionary. If after these two statements, if I print the dictionary, it will not have any c. But still, when you try to print the value of c, automatically it will come as 0. So just see, it is a default dict of type integers, and it has key value pairs a1 and b2 after this point in time. So when you printed DA and DB, that is fine. But even if when you printed default D of C, it did not exist as a key, but still you'll get a value of 0. So this is what default dictionaries do. And next is counter. So whenever you want to count in any collection how many times every unique item is present, you can do it using default dict or dictionaries in general, but counter will do the same job for you in one line of code. So it also creates something like dictionary only. It is exactly like dictionary, but it is of counter object. So you can import the counter library, counter class, and you can use it directly. You can, in the counter class, when you are using the constructor, you can directly pass any iterable, and in that iterable it will count the how many times every unique item is present. So the key will be the unique item and the value will be how many times it is present. Okay, and it will create a dictionary for that. So if I give it a string, string is a iterable, and let's say if I give banana, and if I print C, the counter now, it will just tell me every unique item A is present 3 times, N is present 2 times, and B is present 1 time in the string banana. And you can give any iterable to it basically. So this is how counters work in Python. Cool. Now let's move to practice exercises. So first exercise, again, try to solve the practice exercises on your own first. Only if you're not able to get it, see the solution here in class. So first is program that takes a string and counts the frequency of each character using a dictionary. So they are trying to say that you don't have to use counter here. Okay, you have to use it using a dictionary. You have to create it using a dictionary. So let's do it. So let's say I have a string, and inside the string I have some characters. Let's say, sorry, inside the string, let's say I have some characters. Hi, I am J Bansal. So this is my string, okay, and I want to count again like the frequency of every character which is present. So let us create an empty dictionary. I'm not even using default dict here, okay, because the question has explicitly said you have to use only a dictionary. So we have created an empty dictionary. Now I will iterate over all the characters in the string S, and I will firstly check. I cannot directly say that D of char should be incremented by 1, because the problem with it is that character might not be present, and you cannot say that D of char is equal to D of char plus 1, because when you're trying to access the value D of char, that char might not exist. So if you will have to check that this particular char, we have seen this code in class, right? I'm again just writing it. If this char is already present in dictionary, and I told you every membership operator works on any iterable, it will just check that a particular item is present in that iterable or not, and the name of the dictionary is an iterable over its keys. So essentially we are checking that char is present as a key in the dictionary or not. If it is already present, then you can do this. Then you can increment its value by 1. But if it is not present, then you want to set the value to 0 or to 1 essentially, because you saw it for the first time and hence now its frequency became 1. So whenever you see here, you will say H for the first time. So this character, which means H, will not be present in D, and hence you will go to else and you will make its count as 1, which means its value as 1. Otherwise you will increment it. That's all. At the end of the day, you can print the dictionary, and that is our counter dictionary. Here we can see that H is present 1 time, I is present 2 times, small I, comma is present 1 time, space is present 4 times, A is present 4 times, M, J, Y, B, N, S, L. Okay, so this is the counter that we need. Cool. And you obviously could have used the counter as well. Directly you can do counter of S and you'll get the same thing. Okay, cool. Let's move to the next problem. Program to reverse keys and values of a dictionary. Very simple code. You can do it using comprehension. I already have given you this code in class. You can just write directly the same code. Again, try it on your own first, but using dictionary comprehension, it is a very simple code. Again, when I give you the collab at the end, you will see the solutions to all these problems, homework problems as well. Now next is combine two dictionaries. If a key appears in both, sum the values. So here somehow we are assuming that the value is an integer because that's why we want to add them, or a floating point number. So let's say there is a dictionary. What they are trying to say is, let's say key is something and value is 1. Let's say key is something and the value is something. And there is another dictionary which might have same keys as the previous one. So let's say for key B, the value is 3. And for the key C, the value is, let's say, 4. So here we want to create the expected output. The expected output will be for these two. For key A, the value should be 1. And for key B, since it is present in both of them, the value should be the sum of both of them, 2 and 3, which is 5. And for key C, it is only present in D2, so the value should be 4. Something like this. This is what we want. This is what we want, okay? Cool. So how do I do that? So let's create another dictionary D3, which is the answer. Let's say answer. Answer is my variable that is storing, and it is an empty dictionary right now. So firstly, I will iterate over all the key value pairs which are present in D1, right? So firstly, I can iterate over all the values which are present in D1, and then I can iterate over, actually it's a pretty simple thing, like I can directly make a copy of D1, let's say. Here I can use a shallow copy as well. I don't want to change D1 directly because I want to create another dictionary. I don't want to change the original dictionary which is present. Whenever these type of questions are asked in interview, ask the interviewer what do they want. Do they want to change the original dictionary only, or do they want a separate dictionary and want to preserve the original dictionary? Because these type of questions you need to ask. Okay. So let us create a copy of it, and shallow copy will work because there is no nested structure here. Okay. Now I can just iterate over the second dictionary. So if I say that if for key comma value in D2 dot items, what do we want? If key is already present, if key is already present in D1, if key is already present in D1 or D3, sorry, answer, the answer. If key is already present in answer, it means that it was already there. I just need to add the value. I can just directly say that answer of key should be incremented by this particular value. That's all. Otherwise, I can just insert this key value pair, which is whichever is there, whichever we found, I can just directly insert it. That's all. Right? And at the end, I can print the answer. So here we got the expected output. Okay, now let's see the next problem. Given a dictionary of student marks, create a new dictionary with only students who scored more than 75. So let us create a dictionary first. Let's say in the dictionary I am going to store like how many marks each student got. Let's say Alice scored 67, and Bob scored 89. Let's say Charlie scored 99, and let's say David scored 74 or 75, let's say, because more than 75 is something that we want. And let's say Ella scored 76. So we want all the students who scored more than 75 marks. Okay. So let's create another dictionary answer. It is our final answer, and we are going to print it at the end of the day. So what do we want? We will let's say we iterate over all the key value pairs in the dictionary D dot items again, and I just want to see that if the value is greater than 75, then only I'll add it. So I'll say that if V is greater than 75, then I'll just add it in the answer. That's all. So that's all the code is. Okay. So Bob, Charlie, and Ella actually scored more than 75, but David and Alice did not. And you could have written this code in using dictionary comprehension as well. You could have directly said K colon V if for K comma V in D dot items if V is greater than 75. That would have also worked, because that is like exactly writing this piece of code using comprehension. That's what comprehension does, right? So that's also another way of writing this code. Cool. Now next is flattening a dictionary. Again, flattening is something that we have seen in tuples. Again, try to apply the same logic to dictionaries as well. You just need to check the type of the value. If it is a dictionary, you will again go inside it and add it in this dictionary. So this is slightly like you will need to do some hard work here, and I'll leave this problem as a homework. But again, like I've solved a similar problem in class for tuples. The same thing, you just have to do it for dictionaries here. Okay. So try to do it. I think like you'll get it. Okay. So yeah, that's all. Like I think that's all the problems that we had in dictionaries. And this is all a demo of dictionaries. We learned everything about dictionaries that is important to us. Thanks a lot for watching the lecture. Let's meet in the next lecture. Bye bye.